Hello there. If you're watching this when I'm not live, be sure to check the description so you can skip ahead to the main content. In the meantime, we'll be in the waiting room, so I'll see you soon. Hello, friends. Welcome to Coding Garden. Welcome to Try Day Friday, where we're going to be trying and learning something new. This is the 4th episode of Try Day Friday. The past few Fridays, we've tried various things. Last Friday, we tried PHP and Laravel. Before that, we tried Rust. Before that, we tried HTMX. And today, we will vote on the topic that we're going to try. Godot was a pretty popular one that people had suggested. This is a game engine, a 2D and 3D game engine. People have also suggested Java and Spring Boot, which is a way of building backend APIs with Java. There also could be something machine learning related. This one's very open-ended. I've done .NET before. .NET is like pretty high on the list. A lot of people have voted for it, but I have done it before. So if .NET or C# wins, we would want to maybe I do like .NET Blazor or something that I haven't tried before. Yeah, I haven't done that America 2050. I think what we'll do is just create a list to go by. I mean, ultimately we should shift to using the issues, because that way people can emoji react on the issues, and then we can like arrange by amount of reactions. Yeah. Does it have to be coding? Can we suggest things like Blender? I want to keep it mostly coding related, just because that's why people show up, is to watch me code. But, I mean, I'm not opposed to it. I'm not completely opposed. And Matt, thank you very much for the Prime. I appreciate that. Yeah, but honestly, we should use issues to vote on things. Yeah, I mean, limiting the GitHub accounts I think is okay, though, because we're coders. Dr. Phantom, thank you. Can we use one issue or discussion with ideas as comments, easy to view in one page? Yeah, that's what we're talking about right now. And thank you for that resub. Are you saying have a single issue with the discussion? And Nephi, thank you for everybody's resubbing. Thank you, Nephi. We'll do that in the future, because right now, Godot is pretty high on the list. If we look at this, which we were using for voting, Godot was on, yeah, something right here. And Godot has like 4 upvotes. Machine learning has quite a few upvotes. .NET has quite a few upvotes. So for now, I still am just going to pick a few of the top ones. And then in the future, once we have more and more ideas, we'll have a single issue per one. I'm streaming on both Twitch and YouTube. Yeah, if you go to my YouTube channel, I am live there as well. And David, thank you for the bits. Let's go ahead and honestly, we'll just go ahead and create the poll, and I'll just leave it running in the background. We'll catch up with everyone while it's running in the background. Someone did open an issue, and they mentioned an instant runoff voting website. This is cool because we can have a poll that has maybe like 5 topics on it. But when you vote, instead of just voting for one, you rank them based on your favorite to least favorite. So that way, if your favorite doesn't win, your second favorite vote gets accounted for, and then your votes don't get lost. So we're gonna try to use this today, because ranked choice voting is really interesting. Let me set this up really quick. Okay, what to try? I guess I can show you this. What are we going to try? There will be one winner. How many candidates? We're going to do Godot, Java and Spring Boot, machine learning, .NET, and was there anything else on the Vox website that's really upvoted? We could build a voting app, but so far, all the stuff we've done on Try Day Friday hasn't been anything that will necessarily have longevity. It's just something it's like a one-off thing, and that's mainly what I'm trying to do here. Yeah, I think we're gonna, okay, I think these are the options: Godot, Java, Spring Boot, machine learning, ShadCN, and gRPC. Those are all on, and also .NET. Those are all on the list. So 6 options? 6 options. And then you're gonna rank them from your favorite to your least, or the thing you want to see me do the most to the thing you want to see me do the least. Show results in real time. All right, choice number 1 is build a game with Godot. Now, I have never used Godot. This is an open source game engine. It supports 2D and 3D. And I've already thought about it. If we do this, I want to build a 3D game because I have never done that on stream before. I've only built like 2D games, usually pretty simple games, so it could actually be pretty fun to build a 3D game with Godot. And if this gets chosen, they have 2 options for scripting. There is GDScript, which is like their own language, and then also they have C#. So we would choose that if this wins. Okay, so that's it. Yeah, I don't know which one I'd go with yet. Probably Godot script. I don't know. But if that one wins, those are your options. The other thing is Java Spring Boot. Now, for this, I think we would just build a CRUD API. We'd build a backend API. We'd explore all the features of Spring Boot and like what we can do with it, but we would want to at least integrate with a database and do as much as we can with Java and Spring Boot. The other thing is .NET. Probably something like Blazor. And TG Digital, thank you for the Prime. Let's go ahead and just say Blazor. We would do Blazor because I've never done Blazor before. So first of all, let me just show you Java Spring Boot. This is build a RESTful web service with Java Spring Boot. Maybe we would follow this or something like that, but let's see. Yeah, so it's a whole lot of Java, and you're basically building backend APIs with Java, and it's a framework for it. So they provide things like these decorators like REST controller and Git mapping, and it basically lets you build a backend API with Java. Though technically, yeah, somebody mentioned that earlier. We could technically use Kotlin, and that could be interesting because Kotlin is a newer programming language that you can use for these kinds of things. It can run on the JVM, so you could do Kotlin like with Spring Boot. It's a more modern language than Java. It looks like this. It's fun. See, instead of verbose like Java. So we might, if Java Spring Boot wins, we would vote on whether or not we do Java or Kotlin. And then .NET Blazor is interesting. It is a way of building web applications all with C# and .NET stuffs. But you are able to build web apps, like client-side web apps, but you're using .NET and C#, and then Blazor compiles, I believe, to WebAssembly, which allows your UIs to run inside of the web browser, something like that. Yeah, if we want to know more, we'll watch this this video from Jeff Fritz. He's C# Fritz here on Twitch. C# Fritz, and he does a lot of stuff with Blazor and .NET and stuff like that. But yeah, that's what we would do if that would win. Okay. Next up, we've got gRPC. I would just do this with TypeScript. So gRPC is a way of building an API so that you can have clients of any programming language or any framework, and you can automatically generate the client library based on your backend. But you can also build the backend with whatever you want. So, for instance, they have docs on like all these different language supports. We would do it with node.js. Ideally, and I'm saying we would do it with Node because on these Try Day Fridays, I don't like to mix and learn too many new topics. Like if we tried gRPC with like Java or Kotlin or something, that's just like way too much, because not only are we learning Kotlin, then we're also learning about gRPC. So if gRPC wins, I would do it with Node. But let's just see a quick example. So like you create the server, and then they have this idea of a proto file. So the proto file, it would be the same regardless of what backend language you use. This describes your service and like what are the methods available and what are the data types that it responds with. And then your server basically implements that contract so that it can respond in this way. So that's gRPC. Can we do gRPC in our mono repo so we don't have two things in two repos? Oh, sure, that would make sense. Yeah, because gRPC would be all about the backend, and then we would want to build some client app that consumes that gRPC backend. So yeah, we could do like a mono repo with TypeScript or something like that if we do that. So yeah, okay, so gRPC with TypeScript, and then there was another vote for shadcn, which is a UI library. Though I think they mean the UI library because they have multiple projects. I'm assuming they mean UI. But these, actually, I don't know much about shadcn. I thought they're like very minimally styled components so that you can take them and style them on your own. Like, if we look at components and then we look at button, this is a button. Install the button, use the button. Maybe I'm wrong about that. Maybe you just like, you use it and you choose a theme. Okay, so maybe I'm, yeah, I think I'm thinking about that wrong. I think Radix UI is the one that is like not styled. It, right? Is that right? Let's see, like a button? I don't know. We'd have to look into it, but ultimately, the short of it is it's a UI component library. So we would build an app and pull this library in for our UI components. We'd have to figure out what app we would build. And it doesn't say it, but is it a React library? Yeah, we would use it with React. Oh, you can use it with other things like Svelte? Where does it say that? This is not a component library. It's a collection of reusable components that you can copy and paste into your apps. Oh, okay. That's good. That's also good to know. What do you mean by not a component library? You mean you do not install it as a dependency. It's not available or distributed via NPM. Pick the components you need, copy and paste the code into your project, and customize to your needs. Whoa. Whoa. And so their CLI tool, I'm guessing, generates the code for you that you can then start to modify. Yeah. Ultimately, I think this is for, if you're really trying to build a custom UI, this gives you base components, and then you can start to style them for your app and your product and your company. Yeah. No, I haven't started. I just want to know what it is so people can make a more informed decision about what they vote on. So if we chose shadcn, we would then vote, do we do it with React, Svelte, or Vue? And then based on that, maybe we build like the Coding Garden UI component library. Right? Like maybe we try to recreate the styles of this chat overlay, but using shadcn components. Maybe we do something like that. Okay. shadcn UI. All right. And then was there anything else we want to put on this list? Machine learning. So with machine learning, I mean, there is things like ML5.js, which is built on top of TensorFlow.js to give you machine learning stuff inside of the web browser. But we've done a lot of this before. Really, you just pull the package in, and then you have access to all these machine learning things in your JavaScript codes. It could be interesting to do something with like TensorFlow. The other thing to think about is like, oh, if we choose machine learning, what are we going to do? Because we would potentially want to maybe train our own model on something. I don't know. It's very open-ended. We would have to spend some time figuring out what we do if that wins. Okay, so these are your choices. Build a 3D game with Godot. build a backend RESTful CRUD API with Java and Spring Boot, build some kind of UI-based app with .NET or Blazor, build a backend API with gRPC and TypeScript, build out some kind of UI components with ShadCN, or do something with machine learning. These are your options. Now I need to distribute it. What do I do? Distribute the ballot link and access code. Okay. Cool. Here it is. Go to this URL. Go to this URL. .NET Maui could be interesting too. I've heard a lot. I haven't heard good things about Maui though, because just that it's like it's newer. It still has like growing pains. That's really all I've heard about it. So if you go to that link, that should take you to this. And the idea here is you're going to vote for all of them, but in order of your preference. So if the main thing you want to see me do today is Java and Spring Boot, that should be your first choice. Then choose your second choice, your third choice, your fourth choice, your fifth choice. Can't vote twice. Fifth choice, and then sixth choice. So you're voting in order. And then once you vote, we keep that order. And once enough people have voted, we're going to start to remove the least voted options. But if we remove the least voted option, if that least voted option was your first choice, your votes get redistributed. If that makes sense. We'll see it happen. After you're done voting, we'll see it happen. Let me see if I can grab the results link. Yeah. So this is what the results look like. Basically, we can see a lot of people's first choice is to build a 3D game with Godot. But I think we'll have the option to like remove one of them and then it'll redistribute the votes. That's what'll happen. Actually, give me a second. It's weighted? Too democratic. Yeah, I guess I'm not completely sure. What happens if there's a tie? I've got a slider on the left. Oh. I don't know what this means. The first step is to count all first choice votes. If no candidate reaches 50% of first choice votes, the lowest candidate is eliminated, and those votes shift to second. I see. So because Godot has more than 50%, it's currently the winner. This continues round by round until a candidate reaches 50% and wins. The vertical round slider can be moved to show the round by round changes. So round 1, this was the vote distribution. Round 2, ShadCN got just redistributed. Round 3, that got redistributed. Round 4, that got redistributed. And then round 5, yeah. Does this, I don't think it has admin rights. I don't think it does PHP Gangsta, but thanks for saying that. I think it's completely open because I didn't sign in. Ultimately, you can just you just click the things. It's not changing any results, I don't think. Does Gal Godot? I don't know what Gal Godot is. But regardless, we're gonna leave this running. Let me pin this message in the chat because there is still time for the votes to change. Vote here. I will unpin that. Oh, she's an actress. Never heard of her. Okay, vote there. We're gonna leave this open for another, let's say, like at least 7 minutes. This poll is gonna be open. Right now, it looks like machine learning and Java Spring Boot probably still have a chance. If you can rally people to vote for those, they probably still have a chance. Okay. In the meantime, let's hang out a little bit. Let's catch up. Let's say hello to everyone. So if you would like me, actually, I'll just leave it here. If you would like me to say hello to you, you can say hi, hello, hey, yo, cheers, greetings, hi, us up, what's up, morning, afternoon, evening, howdy, good day, coding hayo, or vohayo. Say any one of those things. I'll acknowledge you and welcome you in. So we're going to go back in time. An hour ago, Mark was the first to say hello. What's up, Mark? Welcome in. Hello to Ariane, good to see you. What's up, Milin and Dr. Phantom and America 2050. Hello, Demerka and Potato Sauce and Abhishek and One Computer Guy and hello, SMC May and Gaurav and David, good to see you. What's up, Harshdev and Veeb and Pablo and Rohit. Hello, Burvi and Oscar I and Bitter and Robert. Hello, what's up, Fob and Jaicom and Aristos and Codex, good to see you. What's up, Moshiko and Tibish and Harsh. Hello, Leet Geek and TG Digital and Bukhari Dev and Ruziv and Stony. How's it going? What's up? Hello, Andreas, Crazy Vulcan, and I just realized the drop game isn't on, so I'll turn the drop game on the screen, anyways. Latara Lopez, good to see you. What's up, Jitesh, PHP Gangsta, Speedstrat, Strategy First, Shake It Bake, Shivam, Stas, Webneat, William. It's been a while, William. Welcome in, and Oitso, hello, and Alana, hello, and Nerdlove, and Steve, and Namantha, and It's a 404, hello, Nero, and Drastic, and Emmanuel, and Jim, and Dev, and Isa Hassane, who says, good to see you too. What's up, Matt? And Deban Hontewari, hello? What's up, Shakib, and Stir Pro, and Amitabh, and Anurag, and Odev, and Anix Gaming, and Fallen Learns, and BS Anis, and Astayanix. It's been so long. Welcome in. Good to see you. And Kathane from Mozambique. Very good. So many people today. Again, this keeps happening. Like old names, new names. And January, February. Hello as well. Yeah, it's good to see you all. I appreciate you being here. If you clear the cookies, it lets you vote more than once. Don't tell anybody that. There's supposed to be a vote duplication prevention. I don't know how it does it. I don't think I have hey guys on the list of hellos. I probably should add it. And what's up, Andreas? I feel like it's been a while since I've seen your name in the chat too. Hello. And from Bangladesh, Shakib. Very good. Why is Netherlands in my stat? No, it's not part of your status. It's when my mouse hovers over, because otherwise I wouldn't know what the state is or what the flag is. And Raven, good to see you. Well, the issue is we have people watching on Twitch and YouTube, which is why we have this external link. The other thing is we wanted to do ranked choice voting, which this website supports. Yeah. Close the tab and click the link again. No way. Oh, that's the wrong thing. All right. Let's do my ranking. First, Godot. Yeah, then Java Spring Boot, then .NET Blazor. Actually, this is just in the order of the order of how I want to do it. Great. And then you're saying I can just go vote again? Let's see. No, it says you have already voted before. Yeah. Yeah, it prevents that. At least it prevents that. Looks like a fight's about to happen. Listen, it's all in good fun, and everything on this list I'm gonna try at some point, right? Today it's probably gonna be Godot, because that is the winner. But next time it's probably gonna be Java Spring Boot. Honestly, we could just use this as our schedule for the next 6 weeks. But maybe not, because things change and people have other suggestions as well. So, and what's up, Believer? Good to see you. Yeah, and Raven, it has been a while. Welcome in. Cool. You wouldn't download a car. What's up, Pablo? Shakib was mentioning they're learning Java this semester. That's good. And Razorson says, you're the reason I started my new app with Svelte. I can't be happier than this. Awesome. Glad to hear it, Razorson. Yeah. Well, the rules have changed, Jitesh. You can cross-stream now. There are caveats to it, but you can cross-stream. Do it in incognito. No, I'm not gonna. No. The order should be randomized to anyone that opens the link. It should be. I think that's the setting that I chose. Yeah. Backlog grooming, yeah. Yeah, the Twitch rules have changed. Thanks. My wife has brought thing. She told me she wanted to go get these. They're like these blind boxes that have like tiny little foods inside of them. Like you could get a pizza or a pie or a cake. We'll open that. It's not candy. It's literally fake. It's like, let me see if I can show you on the overlay or the overhead. You make it so it has like all these pieces in it, and then it's just mini. You don't actually eat it. We'll do that during the next ad break. Okay. Yeah. Spring Boot has more first choice votes than Godot. Huh. What's the best way to learn Java? I don't know. I don't have any good resources for you. Yeah. No, she won't be streaming anymore. No. It's fake food. Yeah. It's like prop miniature food. Okay, the time is up. Yeah, we are going to do Godot. That's the winner today. It should be fun. Let me update my title and everything else. But the plan is we're going to learn Godot. And we're going to try to build a 3D game. So, my results weren't... Oh, I thought they were real time. Oh! It's so close! It's so close! But I'm going to go ahead and go with Godot because now people know how to cheat. I'm not saying that you're cheating, but now it's more likely because people know how to cheat. We're gonna go with Godot. It was the first winner, especially when we can look at the VOD when the timer went off. Who was the winner? It was Godot. Okay, Godot is an open source game engine and game making framework and platform. We're gonna learn more about it. I did some initial reading about it this morning, but I do believe they have like a full-fledged editor you can use. They have their own language called GDScript. You can also use C#. They support 2D and 3D games. And we'll learn more about it, but that's the plan. And we'll also have to figure out what game we will build. But I think first, I'm probably just going to go through their tutorial and build... Like, I might do this. Like, maybe I'll do my first 3D game. Because I already know kind of like the basics of how game engines work. And yeah, well, that's the other thing we'll need to consider. We'll learn about all of this when we go through here. But I did read that version 4 of Godot does not support web yet. And Jim, thank you for the resub. But if you use version 3, you can export the game for web, and then you can like just publish it as a website. If you click the pinned link, that'll take you to the results. Okay, give me 2 minutes to update my titles and everything, and then we'll start trying Godot. Here we go. All right. We're back, and we're going to build a game. Now, let's start with some notes on what do I know about game making, and I guess what I already know about Godot before we jump into it. But yeah, today we are trying Godot. So, what do I already know? I know this is a game engine, and also they have an editor app. Like, they have an app which will let you, like, edit levels and actually, like, edit the code and everything else. It supports 2D and 3D games. So for 2D games, think like platformers, right? So like, or like top down, those kinds of games. But then 3D is literally anything 3D. So like, yeah, like first person shooters, or like, yeah, you're walking around in a 3D world or different things like that. So it supports both types of games. I know that for the language, they have GDScript. I don't know if that's exactly what it's called, but this is a custom scripting language. that is good for beginners. That is a great analogy for all our gamers in the chat. Thank you, Jesus. So yeah, if you're thinking 2D, think of Terraria. 3D would be like Minecraft. Yeah. And then there's also C#, which is just C#. But I'm guessing it's a custom variant of C#. I actually don't know if it's like running on the .NET framework or not. So you would pick which one you want to use. I know that it is open source, and it has a big community. There's a lot of people that like either switched to Godot or started using Godot after all of the fallout that happened with Unity, because for a while Unity was kind of the first choice when people were building indie games or wanted to learn about building games. But I do know that a lot of people have started using Godot instead. I think you can do C# HTML export. We'll figure that out. But let's talk about platform support. In my 10 minutes of reading this morning, I learned that version 3x can be exported to all platforms. So the thing about building like a native game is typically you'd have to distribute an executable, right? Like you have to distribute a binary that somebody would need to run on their computer. So they would have to run it directly on Windows or on Linux or on a Mac. But if you export it as like a web-based game, then someone can just go to a website and play the game inside of their web browser. But as far as I know, version 3 can be exported to all platforms. Version 4, all native platforms. Can't be, they don't yet support export to web. I'm sure they're working on it, but version 4 doesn't support that yet. The extension I have for typos is C-spell. C-spell. Yeah. I think it's 3.x, like the version 3 and below. Yeah, that's what I learned. Okay. What else do I know? That's about it. I don't know much. Let's also, what do I already know about Godot? I also know things about game dev. So what do I know about games? Very often, games will have a update and then draw loop. And I know this because I've built like basic games with like simple JavaScript game frameworks. And I've done a long time ago, I did some basic stuff with Unity. And then also P5.js has this idea of like an update and draw loop. But the idea is you have like the state of your world and all of the potentially objects in the world. I guess it's actually pretty common to do object-oriented programming when you're building games. Maybe it's not the most, I think it kind of feels like it's the most popular thing, but let's say you have all these, let's say you have a world, and then your world has various game objects in it, like people and things and everything else. Each of those things has a state, like where they are in the world, like the position they are in the world, and then also they have the state of their being, like is food eaten or not, or is the person tired or not. So it has all of this state. And so the idea with the update is the update function will call, it'll update the state of all of the objects based on the current state of the world and what has happened. And then we'll go to the draw method, which will render all of the objects on the screen based on their current state. And that just happens over and over and over and over again. So you update the world, you draw. You update the world, you draw. And that's how games work. Now, I actually don't know if Godot works this way. I'm going to assume it does because that's what I have learned about games. But yeah, there's this idea of update and draw. Update the world, draw everything on the screen. Update the world, draw everything on the screen. This is happening like 60 times per second if you want like a 60 FPS game or something like that. Cool. What else do I know? Yeah, I know the concept of sprites. So sprites are basically a large image with multiple states. And you can cycle through the states on the image. And so I know about sprites for 2D games. Oh yeah, maths. Sapnin is mentioning there's a lot of maths. Math is involved. It may or may not be, because the game engine that you're using might actually do a lot of the math for you, but you might have to do things like collision detection. So you're driving in a car, you come up against a wall or a building. Do you go through the wall? Or does the wall stop you? When the wall stops you, does that result in like crushing and damage to your car? So like, yeah, you have like collision detection, and then also just like world physics. So if you throw something into the air, does it fall back down? Like, does it behave somewhat like the real world? Is there gravity, or is the gravity lower or higher? Yeah, there's other things like that involved as well. But let's look at an example of a sprite sheet. For instance, like the game Mario, we could look at a sprite sheet like this. So it's like, if we were to cycle from here to here to here to here, then it would be an animation of like Mario ducking down, and then we could play it in reverse, right? That kind of thing. So you can use sprite sheets for animations. Here's like an old school one. So like, yeah, this is like the running animation for Mario. This is like the idle animation, but then it would go from this image to this image to this image, and then like, well, maybe the jump animation is here to here to here. And so you can cycle through those images. So that's like sprite sheets. I don't know. I don't think we have the same thing in the world of 3D, because in the world of 3D, we have like models. So you have something that represents a full 3D thing. So like, you would literally have a model that represents a person, and that model, a model can be rigged. So like, it has the idea of like arms can move, or like head can move, or feet or like legs can move. And so instead of having a sprite sheet of animations, the model has different moving points, and then a walking animation would basically tap into those rigged points to make it look like it's walking. That's my understanding of it. So, yeah, and so like, you could use a tool like Blender to create your own 3D models, but also there are places where you can get completely royalty-free 3D models and stuff like that. Yeah. We want to do Listed. So a sidetrack. Listed is an app we were working on. I want to do more of it, but what I want to do, and I haven't planned it yet, is I want to do an entire week where we do nothing but work on Listed, with the goal of making it somewhat production ready to launch it. So that's going to happen within the next couple of months, ideally. Okay. Will it change in terms of the view, like first-person view versus three-person view? Okay, so this is actually another thing I know about 3D. So with 3D, it has the concept of a camera. So the idea with building a 3D game is like, technically all of the 3D world exists as a 3D world all of the time, but when a player is playing the game, they're playing from the perspective of a camera. So in terms of like first-person view or third-person view, that's just a matter of changing where the camera is in the 3D scene. Oh, cool! That's a Mario emote. That's very cool. Yeah, that's basically what I know about that. Okay. Anything else I want to mention? Yeah, there are states. There's we have to have state, because that represents every like tick of the game. So yeah, delta time or tick. A tick means like we're moving forward in time by one, and you might have various things happen. Like, I think an example to think about is, let's say we're making a game where we have a loaf of bread, and that loaf of bread gets old and moldy if it just sits on the table. So in the initial state, the bread has maybe like, first of all, it has how old it is. And then we also might have conditions about the room. So like how humid the room is. And then in the next tick, which would be like our like update cycle, we decide, all right, based on the humidity of the room and the placement of the bread, how much life does the bread have before it turns into moldy bread? I don't know why I picked that as an example. But the state of the bread is how old it is, how wet it is, how moldy it is. The state of the room is how humid is it? Is there a window open? Is it sunny? And then all of that is used to calculate what should be displayed in the world. Yeah. And Oitzo is mentioning 2.5D games. I'm not sure exactly what that means, but I do know that some people have built 2D games using 3D. So I mentioned this idea of a camera, and they have basically, like, they made their game in 3D, but they made it so that the player always plays from a 2D perspective. But yeah, okay. That's enough. I mean, you can tell that I have like a cursory knowledge of what's involved with games. So going into this, ultimately, I'm trying to learn how are games made with Godot? What is their ecosystem like? Should I download their editor app? What's the ideal language to use? How do they deal with the update draw loop? How do we deal with 2D versus 3D? These are the things that I want to learn about Godot. All right. And we also are going to answer these questions. Let's jump into the Godot docs. So the game engine you've been waiting for. Godot engine is a free all-in-one cross-platform game engine that makes it easy for you to create 2D and 3D games. Now, what they mean, I think, by all-in-one is it helps with things like assets, so like our sprite sheets or our models. Actually, this is another thing I know about 3D, is the idea of what do you call it when you have like a square that represents like a brick wall? What are those things called? And then you could basically like paint that square over and over again. There's a term for it. A texture. Yeah. So you have like texture. That's the other thing about working with 3D models, is you can have a 3D model that's just bare. It's just like a white person, like a white blob of a person, but then you can add textures to make it look like it's a real person. Like you add a texture that is a t-shirt, or texture that are pants, or whatever else. Oh yeah, tile maps are another thing for like 2D games. And this is similar to sprites in that you have a sheet that represents all the different kinds of terrain in the 2D environment, and then you pick and choose which of those you want to use. But all I want to say, or what I think here, is when they say all-in-one, it has like asset management. Like you have a UI where you can see your textures or your sprites or your tiles. They have a code editor, a place where you can actually write the code. They have like a game preview window. All of these things I'm familiar with because of like Unity, and I'm pretty sure they have a similar thing where basically all of your game development happens inside of one app, but you can go from like testing the game to writing code for the game to like importing objects and all that good stuff. I'm guessing they probably also have like a built-in physics engine and collision detection. All of these things are built in. That's what they mean by all-in-one. We already talked about cross-platform asset management, all one word. But cross-platform means you can build games for Linux, Windows, Mac, and web. That's what cross-platform means. And then makes it easy to do 2D or 3D. And we talked about 2D and 3D was. All right, we're in an ad break, so let's pause for the ad break. And when we come back, we'll jump into learning here. Oh, iOS and Android too. That's cool. But while we're in the ad, let's start to open this thing up. I don't know if we'll open it up. But yeah, this is Miniverse. Make it mini food. We could get ramen, cake, pie, pizza, and we don't know what we're gonna get. So here we go. There we go. Yeah, my wife my wife woke up and she was like, "Would you be mad if I went and got one of these things?" I was like, "No, go do it." And then she was like, do you want one? I was like, sure. Okay, here we go. Let me fix my blue screen really quick. All right. They're so cute. Wait, it's double wrapped. Now I have to do it again? Okay. We might not even get into it before the ad break is over. Oh, there we go. It told us we can tear right there. All right. Let's see what we get. Keep cool. Have a sunny day. All right, I guess we have like instructions. They gave us a platform. Oh, is it gonna be a cake? This is like a little cake platform. There's so much packaging. There really is. And then there's more. Okay. I think what we'll do is during the next ad break, we'll start to open these and see what we got. Because right now, actually, I'll do a sneak preview. I accidentally opened this one. Let's see what's inside. It's just more plastic. Okay, I've decided this is the worst thing ever. I do think we're gonna get a cake though, because like there's another little cake thing, but I've decided it's the worst thing ever because of all the plastic and packaging. Oh, the pink one tells you what it is. We're gonna save that for the next ad break, so stick around if you want to know what we what we got. All right, back to learning about Godot. Just from the homepage, we learned that it's all-in-one, it's cross-platform. Now we're gonna figure out how to get started. We've jumped into the docs. Let's look at an introduction. Yeah, so right now we're on the docs for version 4.2. We can change the docs if we change Godot versions. We could also download the docs, but I don't need to do that. Why don't I have a run ads redeem? I don't think I can. Is it even possible to like constantly run ads? Would Twitch even let you do that? What if on the days where I don't stream, we just run ads 24/7? It's probably not possible. Okay, well, this is our first hello world with Godot. I think that's the other thing is get a hello world working. That's going to be one of our first things probably before we even do like a basic game. All right, welcome to the official documentation, the free and open source community-driven 2D and 3D game engine. Behind this mouthful, you will find a powerful yet user-friendly tool that you can use to develop any kind of game for any platform and with no usage restriction whatsoever. This page gives a broad overview of the engine and this documentation. Okay. The tutorials and resources page lists video tutorials contributed by the community. Cool. If you prefer video to text, consider checking them out. Otherwise, getting started is a great starting point. They have a Discord. They have a Q&A. Cool. Here we go. This is the copy-paste thing that they want us to know about Godot. A game engine is a complex tool and difficult to present in a few words. Here's a quick synopsis, which you're free to use if you need a quick write-up about Godot Engine. Godot Engine is a feature-packed cross-platform game engine to create 2D and 3D games from a unified interface. Yeah, we keep going back to this. It's all in one. It has a unified interface. Basically, we have an app that lets us build and test games. It provides a comprehensive set of common tools so that the users can focus on making games without having to reinvent the wheel. Games can be exported with one click to a number of platforms, Linux, Mac OS, Android, iOS, as well as web-based platforms and consoles. That's super interesting because you could potentially build an indie game for, at least if I understand that right, build an indie game for like Nintendo Switch or the Xbox One or PS5 or something like that. Oh, it doesn't matter. So you can watch on YouTube or Twitch. Yeah, no issue. Godot is completely free and open source under the permissive MIT license. No strings attached, no royalties, nothing. Users' games are theirs down to the last line of engine code. Godot's development is fully independent and community-driven, empowering users to help shape their engine to match their expectations. It is supported by the Godot Foundation. Cool. All right, let's jump into the getting started. You can see that I clicked on this earlier. In this article, we'll help you figure out whether Godot might be a good fit for you. All right, we already have it. It's a 2D and 3D game engine. Great. What can it do? It's been used to build games like X Zodiac and Helms of Fury. I'm not familiar with those games. Yeah, I read that earlier today. Yeah. Okay, this is where Godot came from. So it was initially developed in-house by an Argentinian game studio. Its development started in 2001, and the engine was rewritten and improved tremendously since its open source release in 2014. That's cool. I think the case is a lot of times when before platforms like this existed, anyone that wanted to build a game kind of had to reinvent the wheel every time. Like you had to build your own physics engine potentially, or you had to pay a very high licensing fee to use other sorts of things like that. But the idea that this was built purposefully for a game that they were working on and for their game development studio, then they decided to open source it so that other people could benefit from it. Meow Mew is mentioning, those of you who are familiar with Godot, is it better to go with GDScript or C# since the latter is used outside of Godot as well? Well, I think we're going to figure that out right now, but as far as I know, they mentioned that GDScript is easier for beginners, whereas C#, you do have to technically learn like the C# language, which can be harder for beginners. But I will say you're onto something there, though. If you learn C#, you can use it outside of Godot, right? You can, all the stuff you learn about C#, you could also be used to build like .NET apps or Maui apps or whatever else. That said, if you're learning to program, a lot of programming concepts are also transferable. The syntax isn't transferable, but the concepts are. So, yeah. The Christmas tree blends in so good. Where were the engines back when people were sharing with floppy disks? I mean, I feel like they had to write them from scratch. We don't know what game we're going to make just yet. I kind of have an idea, but I'm going to wait to at least get a hello world, and I want to get a game running before I tell you what my idea is. Okay. As for applications, the open source pixel art drawing program Pixelorama is powered by Godot, and so is the voxel RPG creator RPG in a Box. That's fascinating. Like, they used the Godot app and framework to build an app that other people can use to like build assets. Fascinating. Godot comes with a full-fledged game editor with integrated tools. This is what we're learning, right? So like you have your game and your codes, your folders and your assets. Any objects you select will have like properties on the right, and then you can preview the game here. Did I say flappy disks? The team strives to offer a feature-rich game editor. Of course, if you prefer to work with external programs, we officially support 3D scenes designed in Blender and have plugins for VS Code. That's pretty cool. I think I want to use the Godot editor. I want the full Godot experience. But it is good to know that we could technically use VS Code if we really wanted to. You can code your games in GDScript for a Godot-specific tightly integrated language, or C#, which is popular in the games industry. These are the two main scripting languages we support. With the GD extension technology, you can also write gameplay or high-performance algorithms in C or C++. Okay, let me take notes on this. So, yeah, it's GDScript. What did I call it? I did call it that. Okay. Tightly integrated. C#, industry standard. And then this last thing, GD extension. High performance C++ or C or C++. Now, this is the other thing about making games is a lot of times if you have like really heavy graphics, you typically want like a lower level language because it's going to be closer to the metal. There's less runtime. You can do things faster and like update the screen more frequently, or run more complex code to draw various more complex 3D objects and stuff like that. So it's interesting to know that they do support that which would allow you to make more graphics intensive games. Okay. What do I need to know? Let's keep moving. I want to install it. Scenes. In Godot, you break down your game into reusable scenes. No, you haven't missed anything. We're just getting started. I'm just now looking through the docs. They're already telling me what Godot, what the UI looks like, and I haven't even installed it yet. Oh, but this is the decision I have to make. Do I go with 3.5 or 4.2? Oh no, I guess you're right. They have a web-based editor too, don't they? All right. Let's write this down though. So, scenes. Game is broken down into these. So we might have like a start scene. Then we have a scene that is like level 1, another scene for like level 2. A scene can be a character, a weapon, a menu in the user interface, a single house, an entire level, or anything you can think of. Never mind. It can be many different things. Well, 4.0 isn't beta. It's technically stable. Wait, are you saying I should go with the stable version? Or like the latest version? Godot calls everything a scene. Okay. You can also nest scenes. For instance, you can put your character in a level and drag and drop a scene as a child of it. Cool. Nodes. A scene is composed of one or more nodes. Nodes are your game's smallest building block that you arrange into trees. Scenes are like layers? Maybe? A scene is a component? That makes sense, because if you can have scenes inside scenes, that's the same thing as have like components inside of components. Basically, it's a group, it's a collection of things that can be reused. Yeah, like layers. Layers are components. Nodes are your game's smallest building blocks that you arrange into trees. I see. Scenes are composed of nodes. So we have nodes. Scenes composed of nodes. We have a player that has 3 nodes. Oh, no. This is a character's nodes. The node name is player. It has a camera 2D, a sprite 2D, and a collision shape 2D. Okay. A scene is a type of node? Okay. Godot provides an extensive library of base node types you can combine and extend to build more powerful ones. 2D, 3D, or user interface. You'll do most of these things with nodes. Cool. That's good to know. The scene tree. All your game scenes come together in the scene tree. Literally a tree of scenes. And the scenes are trees of nodes. The scene tree is also a tree of nodes. But it's easier to think of your game in terms of scenes, as they can represent characters, weapons, doors, or your user interface. Okay. Signals. Nodes emit signals when some event occurs. This feature allows you to make nodes communicate without hardwiring them in code. It gives you a lot of flexibility in how you structure your scenes. Okay. If I'm trying to, I guess I mean, maybe I'll see an example of signals, but like the way I think about it is, let's say we're building this moldy bread simulator. The room might emit an event that the humidity has increased or decreased. So that like it sends off a signal, increased humidity or decreased humidity. And then anything else that's dependent on humidity could potentially receive that signal to make their own internal calculations, something like that. Maybe not, but we'll see. I'm gonna make a moldy bread game. Does it exist? If it doesn't exist, maybe we need to make that. Honestly, I like the idea of just simulating the entire world or like the entire universe, right? So like we build a universe object, and a universe is made up of galaxies, and galaxies are made up of solar systems, and solar systems are made up of planets and stars, and planets are made up of continents and oceans, and then continents, like basically just breaking everything down into objects and then like simulating every little object within it. Let's build a universe. Okay, for example, buttons emit a signal when pressed. Okay, we can think of signals as events. In my mind, these are events. They can be emitted. Yeah. Maybe I should just start with moldy bread. Yeah, you're probably right. Other built-in signals can tell you when two objects collided. So when a character or monster entered a given area, you can also define new signals tailored to your game. All right. Summary. Nodes, scenes, the scene tree, and signals are 4 core concepts in Godot that you will manipulate all the time. Nodes are your game's smallest building blocks. You combine them to create scenes that you then combine and nest into the scene tree. You can then use signals to make nodes react to events, and other nodes are different scene tree branches. Cool. I like this. I mean, this is all the stuff we're gonna need. They're starting us here. Good. I think they do more. Yeah, I mean, Twitch likes game dev for sure. First, look at Godot's editor. This page will give you a brief rundown of Godot's interface. I want to launch it. I guess I need to find the section on platform support, because they do mention version 3 versus version 4. And if we are going to build something that we want to be a web game, okay, I mean, that's Cute Pony is mentioning it right now, though. Use version 4. I guess the thing is, eventually version 4 will support web export, but that's what I read this earlier, that version 4 does not support web export yet. Yeah, so oh no, it's experimental. That's fine. We're okay with experimental. So web browsers are experimental in version 4. Using Godot 3x is recommended instead when targeting HTML5. Yeah. Where's there a train icon? All right, we'll use version 4. I want to download it. Here we go. Now I have to make another choice. do I want Godot Engine, or do I want Godot Engine? I see. If we want to do C#, we have to choose the .NET one. If we don't want to use C#, we choose the other one. This, my friends, is where we vote. Do we do GD script or C#? Here's the thing. I want to show you examples of both somehow. And then you can decide. Do we need to? Everyone's saying just use GD script. I should use that. I guess if we choose that, we get the full Godot experience. But yeah, okay, here's one example. If we were to write this code with C#, we would have a player class, it would have a speed property, and a screen size property, but if we did it with GDScript, we would just, oh, in this case, we're inheriting from the area2D class. In this case, we don't even define a class. We just say we're extending. I guess this is in its own file that defines the player. So this is like a file called player. And then your properties are just variables that are then available. Yeah, they're using var here. Okay. Here's another example. We've got a public method called ready. When you call that, we grab the screen size. And so get the viewport rectangle, and then that returns an object, and then we can access the size property. With GDScript, similar thing. We can see the conventions in GDScript are to use underscore case, though. But it's a similar thing. Call it, get the size. They also have funcs. All right. Here we go. Here's some more codes. If we look at C#, we have a method called process. It takes in a double. So the thing is, C# has vars, but they're not dynamic. A var just infers the type from the right-hand side. From what I've heard, GDScript actually isn't strongly typed. Is that accurate? Does learn X and Y minutes have GDScript? They do have GDScript. Yeah, it's a dynamically typed scripting language. So we can use our JavaScript brain when we're looking at this to know that like a variable doesn't necessarily have a type. You can like reassign it to be something else. Not that you would, but it is possible. Static typing in GDScript. Okay. In this guide, you will learn how to use static typing. A brief look at static typing. With static typing, GDScript can detect more errors. All right. How to use static typing. This feels like TypeScript, right? It's like you're still... TypeScript is just editor support on top of JavaScript. Basically, it's like... it's like a linter, I guess. And in a way, this is type hints for it. So we probably wouldn't jump into type hints immediately because I think a lot of the tutorial probably doesn't have type hints on it. But it is nice to know that we can adopt typings once we get the hang of things. All right, I'm still going to let you vote. I have my own opinion, but I still want to see what the chat is feeling. So we'll just do like a 2-minute poll. What do you want to see me use to write this game? Do we use C# or do we use GDScript? TypeScript? TypeScript isn't an option. Yeah, I think that's the other thing. So like if we look at this example, one of the conventions in C# is to put the curly brace on the next line, which makes it look a lot more verbose. In JavaScript, we're used to putting that curly brace on the previous line. I mean, you can put the curly brace on the previous line in C#, but it's just not the convention to do it. I guess there are no curly braces in GDScript. It is a white space-based language. I think that's what we're learning here. So similar to Python, it uses white space to denote blocks. So the fact that all of this is indented means we're inside of a block right here. Yeah. And maybe like to access static classes, we're using like $sign here. Maybe I don't know what that $sign is for. Yeah, it does look similar to Python. Okay. Ooh, it's close. All right, I'm gonna give you 30 seconds to vote. $sign is shorthand for get node. Get the animated sprite 2D node. In this case, the node is just a property on the class. If we plan to export to web, check this out. Let's see. Yeah. Welcome in, Sarah Knight. Good to see you. It was close, but we are going to use GDScript. That's where I was leaning as well. A lot of people in the chat were saying we should use GDScript. We're going to use GDScript, which means we're just going to download this one. It's only 90 megabytes. That's cool. Read the warning for Mac. Oh, on exporting for web. Godot 4's HTML5 exports currently cannot run. No, 90 megabytes. It's fairly small. Cannot run on Mac and iOS due to upstream bugs. We recommend using macOS and iOS native export functionality instead, as it will result in better performance. Okay, so is this telling me I can't export for web on Mac? But if I use the web version, would I be able to export for web? I'm on a Mac. I have to use it. Ads are gonna happen in 30 minutes. All right, we now have the Godot app. Let's launch it. See what we get. Wow, you currently don't have any projects. Would you like to explore the official example projects in the app asset library? Yeah. No results compatible with Godot 4.2. Why not? Community. Fascinating. I'm just gonna go for it. Let's create a new project. Hello world. Let me make a folder for all my games. Exiting or exciting? Are you excited? All right, I've created a folder. What renderer do we want? Forward Plus supports desktop platforms only. Advanced 3D graphics available. Mobile supports desktop and mobile. Compatibility supports desktop, mobile, and web. Least advanced 3D graphics, intended for lower end and older devices. Let's do that. I want to be able to run this in the web browser eventually, so yeah. Version control metadata. Sure, let's go. It's happening. Yeah, the logo is fun. I like it too. Wow. Okay. First test. Does it support being smaller? It does. Okay, so we have ourselves a little 3D thing. That's fun. Whoa! We also have 2D. Whoa. Okay, and then we can create scenes. We can create user interfaces. We have our scripting. Okay, so now that I have it running locally, I'm gonna relay back to this when we are looking at the getting started here. Oh boy, here we go. Getting started, step by step, creating instances. Okay. In the previous part, we saw that a scene is a collection of nodes organized in a tree. You can create as many scenes as you'd like and save them as files with the TS scene extension, which stands for text scene. Here's an example of a ball. It's a rigid body 2D, which allows the ball to fall and bounce on walls. Once you save a scene, it works as a blueprint. All right. Let's use instancing in practice to see how it works in Godot. We invite you to download the balls sample project. Let's do that. All right, extract the archive and then import it. So now it says go to project, quit, and then import. Local, import. The drop game is this. It'll drop an emote from the sky, and if it lands on the tree, you get your name on the tree for a little bit. All right. Yeah, I removed the snowflakes this morning because I was like, we'll use the drop game, but it's just not Christmas anymore. This project was last edited in Godot 4. Opening will change it to Godot 4.2. Sure. It's thinking. The pin chat should be gone. Yeah, I think the pin chat is gone, right? Yeah, I think I'm gonna jump into 3D game like after we get the hang of everything. Maybe I should just go straight there. But yeah, okay, we've imported it. It contains 2 scenes. Main contains the walls and ball. So where is main? Do I drag it? Do I click it? Ah, we have to go to 2D because this is a 2D game. So in order to see the scene, we need to be under 2D. So we have main. And where's the ball? Oh, look at him. All right. And yeah, I guess if we run the game, it should do the thing. Yeah, I might full screen it once we get into it. Wow. Look at our lovely game. Gaming on a Mac, exactly. But yeah, that's the thing to note. It has physics, right? So we click it, drops. Wow, okay. Let's add a ball as a child of the main node. In the scene dock, select the main node, click the link at the top of the scene dock. All right. Click it. Instantiate child scene. So this is saying, click the link, choose ball. Where's my scroll wheel? Here. Okay, and so that created a ball in the scene, and I can drag it around. And you know what this means? This means that now when we start the game, we should get 1 ball for free. Look at that. So So we've added an instance of a ball to the main scene. That's fun. Game of the year, exactly. Click it and drag it towards the center. Play the game. You can repeat this until you have several in the scene. Editing scenes and instances. Change the properties of one ball without affecting the others using the inspector. Change the default properties of every ball by opening that. Cool. Open that ball thingy and select the ball node. All right, so if we click on ball, this opens it. We select the node. That gives us our properties over on the right. Yeah, this is collision shape 2D. Over here, they call it the rigid body 2D. Is that new? Or am I looking at the wrong thing? Oh, I want to look at the whole thing. The whole thing. I want to look at the ball. Right now, I was just looking at the shape. But if we look at the whole ball, we see it. Okay. Set its bounce property to 0.5. We have gravity scale. Center of mass. I don't see any of these. Click the physics material. Oh, I see. This thing. Click that. Now we can set the bounciness. Set it to 0.5. And that should change the bounciness of all balls. And so now balls will look at that bounce. Wow. I guess the other thing is, let's go crazy. A bounce of 2. Yeah. Okay. All right, I'm over it. Let's make our first 3D game. In this step-by-step tutorial series, you will create your first 3D game with Godot. By the end of the series, you'll have a simple yet finished project of your own, like the animated GIF below. The game we'll code here is similar to your first 2D game. I guess that's the issue. Is it dependent on me making that 2D game? Where do I get ideas for games? I don't. I don't make games. Yeah, I said GIF the right way. Okay. You will learn to work with 3D coordinates with a jumping mechanic, use kinematic bodies to move 3D characters and detect when and how they will collide, use physics layers and a group to detect interactions with specific entities. Draw a user interface on a 3D game. This tutorial is for beginners who followed the complete Getting Started series. Oh no, I skipped I skipped all of this. I skipped all of this. We'll start slow with detailed instructions and then shorten them as we do similar steps. If you're an experienced programmer, you can browse the complete demo source code here. You can follow this series without having done the 2D one. However, if you're new to game development, we recommend you start with 2D. YOLO. Yeah, let's do it. We prepared some game assets so we can jump straight to the code. You can download them here. All right, let me download. We're going to do it. We're jumping in. If I come across something that I don't understand or don't know, we'll go back to the docs and figure out what it is. Yeah, how hard could it be? It's gonna be easy. I know how to program. Okay. This says, we will work on a basic prototype for the player's movement. Then we will add the monsters that will spawn randomly around the screen. After that, we'll implement the jump and squashing mechanic. All right. In the first part, we're going to set up the game area. Let's get started by importing the starting assets and setting up the game scene. So yeah, I downloaded the assets. Now we need to import it. At least I learned this. Quit to project list. import, and then squash the creeps. Import. The selected project was generated with Godot 3. Oh no! Let's convert it. Here we go. It could be a long tutorial. Also, I could have completely messed it up by converting it to Godot 4. Now maybe it's not going to align with the. Why do I have node modules in my home directory? Honestly, I think because of ESLint. I have like a global ESLint. In the import pop-up, enter the full path to the freshly created directory. We did that. Navigate to that. Import. Great. The start project contains an icon in 2 folders, art and fonts. Here they are. There are 2 3D models, player and mob. Some materials that belong to these models and music track. Setting up the playable area. We're going to create our main scene with a plain node at its root. In the scene dock, click the Add Child node represented by the plus icon. All right, we're on scene. We want to add child node. What kind of child node do we want? Oh, just node. Node. Create. Rename. Main. We've done it, everyone. We created our first scene. I think that's what it wanted me to do. Rename it to main. First try, yeah. Okay. Yeah, I right-clicked and renamed. Good. Save this as main.tsn. All right, so if I do Command S, call it main. Okay, now it exists in my project structure. This is good to know, because I mean, like, the relation between these two things, I guess what I'm gathering is, over here, you can inspect the thing, but like not unless you've saved it somewhere, you're not going to be able to reuse it. And so by saving it here, now it's reusable and potentially editable. Okay, we'll start by adding a floor that'll prevent the characters from falling. To create static colliders, you can use static body 3D. All right, so we want to add a static body 3D, a collision shape 3D, and a static body 3D. And then our scene should look like this. All right. So we want, on main, we're going to add another one. It's going to be a static body 3D. Yep. We're going to call that ground. And then within that, we are going to create a collision shape 3D. Cool. Yeah, I see this warning icon and I'm worried, but I click it. A shape must be provided for the collision shape 3D to function. Please create a shape resource for it. Okay. To create a shape, select the collision shape 3D node, head to the inspector and click the empty filled text to create a new box shape 3D. All right, click it. And then it wants us to click over here to choose the box shape 3D. Ah. The box shape is perfect for a flat ground and walls. Ah, see, we're creating a floor. I'm following. We have a box, but we're gonna flatten it, extend it. We're gonna get ourselves a nice little floor here. A box wireframe appears in the viewport. Oh, look at me! I can move it around. All right. You can click and drag and edit these shapes. Okay, so if I want to make it wider, yeah, look at this. We can make a skyscraper, or we can create Actually, how do I wanna move around? How do I move around? Hence the name ground, yes. um well, but look, look at me, I'm making a floor. I mean, I'm trying to make it entertaining, Veritas. It's like I made a box. Yeah. Hold space and click. I guess I could zoom out. But yeah, I'm trying. Yeah, I want to like click to pan. Oh well. To expand the resource, set the size to 60 on the X. Okay, so yeah, we could do it manually like I was just doing. But if we look at the box shape 3D, we can see that we're modifying this X, Y, and Z whenever I do these things, we're modifying the X, Y, and Z. And so if I wanted to do it manually, I could, but we're gonna want a specific X, Y, and Z. So set the size for X to 60. Wow. Set the size for Y to be 2, and Z will be 60 as well. Wow. Right mouse. Also, I shouldn't be translating this. I don't know where the translate gets set, but we have made a ground. Collision shapes are invisible. We need to add a visual floor that goes along with it. Yeah, WASD arrow keys don't quite do anything. I can zoom out, but like, I don't know. Am I holding right click? No, should I? Oh, okay, that's better. That's changing the camera. Yeah, I see. And then middle click goes like this. Right click goes like this. Shift is what I'm looking for. Shift, middle click, shift. Yeah, shift, middle click. Ah, I guess this is another way to look at it too. Cool. All right. On the ground, we want to add a mesh shape 3D, it says. Mesh instance 3D? And this is going to make it so that our ground is no longer invisible. We're going to give it a texture, I guess. In the inspector, click on the mesh and create a box mesh. New box mesh. Ooh. Once again, it's too small. We're going to set it to 62.2. But you'll notice, I need to somehow connect it to the collision shape. 6260, that's why. Okay. But yeah, now we have this, but we need to combine it with the collision shape. Select the ground node, hold the control key down to turn on grid snapping. Select the ground node, control. Is it command on a Mac? Reset transform under node 3D. Mesh instance. We also want to reset the transform. So yeah, that reset it back down to the ground. And then where's the transform on our mesh? Scroll down. Here it is. Reset. Nice. Now they are in the same spot. And I should stop moving them around. Because every time I click, it moves it around. I want this, or like right click to. I should be right clicking to move things, not pointer click, main click. I don't know. Left click. All right. Select the ground node. Hold the control key down to turn on grid snapping, and click and drag on the y-axis. It's the green arrow in the move gizmo. Move the ground down to 1 meter. So click control. I see. It's snapping. Without that, we get a decimal. If you see the translate, we get a decimal. But if I hold control, now it's snapping by 1. Oh, it wanted me to do this one? But it wants me to do -1. Okay. Let's add a directional light so our scene isn't all gray. Select the main node and add a directional light 3D. Oh. You can light it up. Very cool. The unit's in meters? Okay. You have a directional light. Move it up by clicking and dragging the red arc to rotate it around the x-axis until the ground is lit. Should I be using a right-handed mouse? How's it any different? Move it up by clicking and dragging. I reset the transform on these two things, though. Thought I did. See? Transform is... Oh, maybe the ground transform hasn't been reset? Yeah, there we go. Yeah, okay. That's the main issue. Yeah, we reset the ground transform. We've got this. Let's reset that transform. And then it was saying if we drag it in the red, we should see a change. I see. We reset it now. Now. -1. Great. Oh, move it up by dragging the green arrow. I was dragging the red arrow. Okay, so now we go to directional. Also does nothing. Do we reset the transform on it? Click and drag the red arc to rotate it around the x-axis. So like pull it up. Show me the light. I can't see the light. Everyone, all the Godot people are like, what are you doing? The arc, not the arrow. Which one's the arc? What's the difference? The curve. Okay. Wow. Okay. Yeah. Now we can see it getting lit up. I still have to get the hang of navigating this because I can't quite get the view on it that I want. Pulling the arc. Oh, okay, look. It's now lit up. Not lit up, lit up. I'm getting motion sickness. But do we also move it up? All right, ad break is coming up, and all we have is a 3D scene. But that's okay. In the inspector, turn on shadow by clicking the shadow box. So click here, and then shadow, turn it on. Okay, at this point, your project should look like this. It kind of does. It sort of does. It's like I still can't get the camera where I want it. Oh well. That's our starting point. Let's add a player to the scene. All right, speedrun. Can I add a player in 1 minute and 30 seconds? All right. Create a new scene by going to the scene, new scene. So scene, new scene. All right, we have the new scene. Then we want a character body 3D. So we add it, we search for character body 3D. Okay, great. Now we rename this to player. What's the rename shortcut? Just enter. All right, we have a player. Add a 3D node as a child and name it pivot. So here we add 3D node? What? Node 3D. And name it pivot. All right, then in the file system doc, expand the art folder and drag the player. So we go art, player into pivot. Whoa! You can rename it to character. Now we're cooking with oil. Okay. We need a collision. So select the player, collision shape 3D, player, collision shape 3D. So now the player will be able to collide, but we have to remember we have this little icon. We need to do the thing where we tell it that is a sphere shape 3D in this case. So we go here, new sphere shape 3D. So the collision box is like a sphere in the center of the thing, and I'm guessing maybe we're going to expand that sphere. So the sphere has a radius of 0.8 meters. Boom. Okay. And now the ads have started. Not bad. Not bad. We got ourselves a little player on the screen. All right. I guess after this, yeah, this okay, we're on our way though, right? Because we have our 3D player. Now we need to add controls, like to move that 3D player around the floor, etc. All right. Quick break during ads. We're gonna keep opening this this thing here. All right, next package. Ooh, we got tongs and a fork. And also some kind of ball. All right. The pink one. Oh, it's a bundt cake, red velvet bundt cake. Look at that. Wow. Do I want to remove it from its container? Or do we serve it like that? I think I do, because this piece. Ah. Well, we won't throw this away though. We'll hold on to more plastic. Yeah, do not eat this, everyone. This is not actual food. Oh, is these sprinkled? No, they're chocolate chips. Look at that. All right. Last one. Glaze. It says do not eat. Do not eat. Oh, and then it has a little topper for the glaze. Oh no! But all right. Does it just go on top? No, I should be able to pull off the do not eat warning. Right? This doesn't unscrew. Or does it? Oh, there's a tape on it. What's going on? We're breaking for ads, and I'm opening this little fake cake. Wait, is it actual goop? Do we get actual icing? We do! Wow, it's resin. I see. So the resin will harden when we ice our cake. Okay, I'm not going to do it now. That's for the next ad break. And then oh man, this is not very stable. It keeps falling. Where does this go? I see. So we'll probably pour the resin and then the sprinkles. Oh yeah, the sprinkles actually do come out. Okay. I can smell it. I'm gonna close it. This this smells like chemicals. I'm gonna put that one back on for now. Yeah. I don't want it to dry up. And then I guess we can place the sprinkles with that. We can eat it with that. And then I don't know what this is for yet. Is this like the topper on the cake or something? Also, do one of these have instructions in it? Oh, here we go. Read me first. Once you have our dish or drink prepped, place it under daylight or UV light with a tray. Set the resin for at least 5 minutes. Small plastic ball goes in the large clear plastic ball. Like that. Oh, is this going to be a cover for... Oh, I see. It's going to be a cover for our cake. So, like, this buddy goes in there. Once we set everything, we have a little... Is it a cloche? Is that what you call this? I forget what you call it, but you can cover... Yeah. Okay. And we'll probably glue this to that. So that way... Well, don't do that. Now the camera's flipped. Oh wait, we'll handle that later. Back to our game. If you are just joining us, we're learning Godot, and we have a 3D player on the screen. Look at this. We added so this 3D object, player.glb, was included in our assets, and we've added it to this scene here. And then we also added the collision shape 3D. So by default, a 3D object doesn't necessarily have a collision box, meaning like in our game, how is this thing going to know when it collides with something else? But by putting this collision sphere, now when this is within the game, it'll be colliding according to that collision sphere. That's what we've done so far. And also GLB, I'm curious if that's a common type of 3D model. Too many requests. Yeah, so this is the other interesting thing. We can find potentially free 3D models online. Some models have licenses, like you can't use this in a commercial product or whatever else. But there are a lot of Creative Commons Zero free models out there. So when we're building our own game, we could find some and and add them to our game, like a tree. Whoa. Let's look at like bonsai trees. And Barbacuda, thank you for the prime. Appreciate you. Yeah. It's a Cinema 4D. If it's not GLB, we probably could find like a GLB converter, or Godot might also support these other types of models. And then we could bring it into our game. A 3D drop game? I actually don't know what that would involve. I'm gonna go ahead and tell you my idea that I had this morning. It's not the best idea, and we would have to expand on it. But I want to create a commute simulator. So I found some 3D models of like a bunch of different cars that are like PS1 style. And I found some 3D models that are like roads and buildings. And the game would be that you get into traffic and you just sit there and try to commute. That would be the whole game. It's a commute simulator. I don't know. We could come up with mechanics. I don't know. Like maybe there's like a radio that plays, and then I don't know. Okay, so we're at this point. We added the collision thing. Yeah, it's like a real time commute simulator. Like the clock moves in normal time. I don't know. It probably would be super complex because you would need like all of the other cars would have to be like autonomous. Yeah. Okay. Move the shape up so its bottom roughly aligns with the grid's plane. So at this point, we have this roughly aligns like there. There. You can toggle the model visibility by clicking the icon next to the caret or pivot nodes. Yeah. Add the collision shape to the player layer, not the character layer. Ah, okay. I see. It needs to be at the same level as the pivot. Cool. And then that allows us to hide the character, but not everything else. Character and collision should be siblings. At this point, it has collision as a sibling of pivot. Okay. Save this scene as player. Okay. With the nodes ready, we can almost get coding, but first we need to define some input actions. Oh, no worries, JD. Yeah, and thank you to Mr. Dream Studio for helping out. Though your comment asks is, I don't know if you know how to read or not. That's not what you were saying. You're just like, I don't know if you read the instructions. Like, this guy can't read. I don't normally do game dev. I'm usually like a full stack web developer. Okay. Now, to move the character, we'll listen to the player's input. Like pressing the arrow keys in Godot, we could write all the key bindings in code. There's a powerful system that allows us to assign a label to a set of keys and buttons. This is an input map. So go to Project and then Project Settings. Project Settings. Input map. The window allows us to add new actions, and then you can bind these actions. Projects come with predefined actions. We're defining our own to support gamepads. We're going to name our actions, move left, move right, move forward, move back, and jump. To add an action, write its name in the bar. All right, so like move left. And then create it. So we want move left, move right, move forward, move back, jump, left, right, forward, back, jump. Okay. Yeah, I mean, typically there's devs of all kinds that are here. So yeah. To bind a key or button to an action, click the plus button and do this for move left. All right, so for move left, we want to add the keyboard key left. Yes, we're adding the left physical key. And then I guess we're also going to be binding WASD. So left on WASD is A. So we will also bind A. What's the easiest way to find this? Oh, you type the letter. There we go. Yeah, so physical A. So you can have different output targets. Because I'm on a Mac, I don't think I can output this for web, but I technically could build it for Windows or Linux or Mac or mobile, I think, as well. All right, same thing for move right. And then right is D. And then forward is up. And also W. Oh, no. And then back is down. Well, I'm in version 4, and there's an issue right now. They're going to support it eventually. Version 3 definitely supports it. And also S. And then jump is spacebar. Is that what they want us to do? Let's now add support for a gamepad's left joystick. Click the plus button. Manual, joypad, axes. Select the negative x-axis of the left joystick. What if I don't want to use I don't want to use a gamepad? I'm not going to go through this to use a gamepad. All right, what is jump going to be? The space key and the gamepad's yeah, okay. Yeah, we're just going to do keyboard actions, no joypad. Great. So now we've mapped all of those things. When these buttons are pressed, it's going to fire an action like move left, move right, and then we probably need to handle those actions somehow. Moving the player with code. Right-click the player and then attach script. Call it player.gd. They're doing a capital P player. We want the template to be empty. Object empty. Here we go. Create. Wow, okay. Enhance. We have a few properties. We have the speed of the character. we have the fall acceleration and the target velocity, which starts off as 0. Target velocity is a 3D vector combining speed with direction. Yeah, so as the game ticks, we're going to be changing our velocity. Yeah. Good to know JD does dev. The pre-filled template would have had a bunch of this stuff for us. Yeah, and Murdoch is saying, hello, what's up, Murdoch? My recent project has been in Godot. My character animation script is 230 lines long, and I'm only 2/3 of the way done with the sprite sheet. Nice. Okay. So in 3D code, distance is in meters. It's good to know. Now we're going to do the movement. We start by calculating the input direction vector using the global input object in physics process. So I'm guessing here is like a method override. So because we're extending character body 3D, a character body 3D has a physics process method that we can override and do our own codes inside of here. So when this runs, we'll check to see what keys are pressed. And depending on what key is pressed, we change the direction. Yeah, and earlier I talked about a game loop, which has like an update and draw. I'm guessing this runs over and over again. So this is, yeah, so that's what JD does dev just mentioned. It runs every tick. So this runs and we say, are we moving right? Are we moving right? Or are we moving left, right? Are we moving right, left, back, or forward? Next tick. Are we moving right, left, back, or forward? And then we can determine that on every tick. Okay. We're gonna make all the calculations using the virtual function. Like process, it allows you to update the node every frame, but it's designed specifically for physics-related code like moving a kinematic or rigid body. Okay, physics process runs every tick. We could learn more. We're going to keep going, though. Yeah. Hardest thing is not thinking like a web dev. Things don't need to be as optimized, and we're not worried about minimizing HTTP requests. I never think about those things as a web dev, but maybe that's just me. Why does the back and forward move the Z direction and not the Y? I think that just has to do with our 3D world. So, I'm actually not clear on what the X, Y, and Z are yet. Is this a bug? Why is it not showing? Why can't I see the main when I click on the main tab? It's only showing the player script. This is a bug. I closed, or is it? Like, I closed the player script and it, oh, I'm on the script tag. I see. I have to go over here to see it. And then we could open main back up. Great. What did I want to show? Oh yeah, I want to understand the Y. So Y is green, which would be up. And then Z is in the blue and X is in the red. So that's why. So because of this plane, we're working with X and Z. If we did Y, we would go up. And for this game that we're creating, we don't want to go up. So that's why in the player script, we're affecting Z, not Y, because we don't want to go up. We want to go within that plane that's defined there. We start by initializing a direction variable to 0, then we check if the player is pressing one or more of the move inputs. Right. In case the player presses, say, both W and D simultaneously, the vector will have a length of about 1.4, but if they press a single key, it'll be a length of 1. We want the vector's key to be consistent and not move faster diagonally, so to do so, we call its normalized method. Okay, so calculate the direction based on what keys are pressed, and then after that, update the direction by normalizing it. It's interesting to see in the editor. So because this is a white space based language, it's showing us our space characters or our tap characters. And so if the player did move, because we defaulted to 0, and then if they move, we update it. But if the player did move, we normalize it, and then I guess we're changing the camera position. Let me hide the drop game for a little bit. Pivot, look at the position that we're moving. So as we move, it's going to potentially change the. Maybe it's not the camera. It's the direction of the player that we're changing here. We call it look at method. This method takes a position in space and looks at the global coordinates in the up direction. In 3D, the property that contains a node's position is position. By adding the direction to it, we get a position to look at that's 1 meter away from the player. Then, when we update the velocity, we have to calculate the ground velocity and the fall separately. Okay. Okay. So, normalize the direction, change where the pivot is looking, and then target velocity is the actual velocity of the player. And then we're modifying that here based on direction and speed. But where does speed but we have speed defined here. So based on what what keys were being pressed, WASD or left, right, up, up or down, that determines our next direction. We then change our current velocity based on that in combination with our speed. If we're in the air, fall towards the floor. Yeah, so right now our movement is only on the floor. I'm guessing we're also going to handle jump, and jump will move us in the y-axis to move up, and this will move us back down to the floor. So if in the air, fall towards the floor, literally gravity. so this is the gravity that would bring us back down if for some reason we're not on the floor. But as far as I can tell, we haven't done anything to modify the y-axis, so we wouldn't really even be off of the floor. Then where's velocity defined? I'm guessing, do I get any sort of hints here? But I'm guessing velocity is just a property of the character body 3D. And so here we're overriding that internal property. Like to me, it was a little bit confusing because we didn't see it defined anywhere, but I'm guessing every character body 3D has a velocity, and then we update it to be our target velocity. Cool. Now, move and slide, we haven't defined yet. So we're going to move on to that next. Yeah. This is like a more fun version of my freshman engineering physics class. I mean, I guess you're learning with me. I'm also telling you what I think as I read the code because I know how to program, and I'm not just coming at this completely blind. Like knowing that velocity is potentially a property on the base class, you have to be a programmer to know that. Yeah, move and slide is already included. Oh, lookup symbol. Wow, moves the body based on velocity. Very cool. Yep, sounds good. Here's the complete script. We've got that. Testing our player's movement. Here we go. We're going to put our player in the main scene to test it. To do so, we need to instantiate the player and then add a camera. Save your player scene and open the main scene. Save. Instantiate the player. Right-click the main node and select Instantiate Child Scene. So instantiate Child Scene, and we're going to put a player in there. There they are. They're on the floor. And then we need to add a camera. Let's add the camera. Like we did with the player's pivot, we're going to create a basic rig. On main, we're going to create a marker 3D. Yeah. Yeah, that's at the same layer as the same level as the player. We're going to call this camera pivot. And then we add a camera 3D to that. Okay. Notice the preview checkbox that appears in the top left when you have the camera selected. So we have the camera. Let's preview it. Ah, so now we're inside the player. So we need to change like the camera position so that it's not in there, and I guess it becomes our view of the game. We're gonna use the pivot to rotate the camera as if it was on a crane. First, split the 3D view to be able to freely navigate the scene and see what the camera sees. View. Oh, okay. In the bottom view, select your camera 3D and turn the camera view preview on. Okay, so in the... Oh, it wanted me to do top-down 2 viewports. In the bottom view, select camera 3D and preview. In the top view, move the camera about 19 units in the z-axis. Do we want the top view to be camera preview as well? In the bottom view, select camera 3D and turn on the preview. In the top view, move the camera about 19 units on the z-axis. Oh. Wow. So this is changing what the camera sees. So on Z, we'll do 19. Okay. Yeah, this is about what we're seeing here. Here's where the magic happens. Select the camera pivot and rotate it -45 degrees. Select the camera pivot. Rotate -5 degrees around the x-axis using the red circle. It's coming to life! This is our game! So this is what the player will see when they're playing the game. They're seeing like the top-down view. Okay, so we want hold control, we learned that, and we can go 45? Yeah. -45. Boom. All right. You can run the scene by pressing F6 and then press the arrow keys to move the character. That's crazy. So at this point, let's save everything. Because we set up, no main scene has ever been defined. Select one. Main. But we set up player movement and we set up the camera. So, wow. But I guess he has no velocity. So because it has no velocity, it's not moving. Maybe this isn't right. But I mean, it's doing something. Let's see what this tells us though. Did we set up space? No, we haven't. We haven't handled the space bar yet. You can run the scene. We did that. You can see some empty space around the character due to the perspective projection. In this game, we're going to use an orthographic projection instead to better frame the gameplay area and make it easier for the player to read distances. Okay, so select the camera again. Camera. Projection to orthogonal. Ooh. Size 19. Oh. When using an orthogonal camera, directional shadow is dependent on the camera's far view. All right. Test your scene, and you should be able to move in all directions and not glitch through the floor. I think I messed something up then. Because I'm not moving, I'm just rotating. I messed something up. I missed something. Let's look at our player script. Okay. Speed 14. Fall acceleration 75. Target velocity 0. I mean, let's just copy everything in case I'm missing something. Maybe you're not supposed to be able to move? Because this is just changing the direction. But it is changing the velocity. I don't know. Designing the mob scene. In this part, how would you know that? I guess that's true because of the camera angle. You can't really. I guess I would expect it to like move around, but does it need a speed? Where does the speed get set? No, speed is 14. I think our indentation looks good. Print out your position. How? In the script. Here's the language reference. I want to see, how do I print? Print text. Print line. Position? Yeah, so we have access to position. Also, it's curious that they have semicolons and we don't have semicolons anywhere else. Oh, wait, are we looking at the right? This is C and C++. This is not right. It's just print. Yeah, print. Position. Okay. Zero, 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 zero. Yeah, the position isn't changing. It's always 0 on every update. It's always 0. Is that accurate? I want to play this game, Limo says. Only, yeah, I guess that's the thing, is like our code only updates the direction. It actually doesn't. I guess it changes our target velocity, which in turn should update our position based on move and slide, right? I can't recommend anything because this is my first time using it. It seems cool. I mean, they have a ton of documentation. It's all open source. It seems fine. Position is relative to the component. I see. That's good to know as well. I was just printing the position of the thing. But if we do global position, that'll be in relation to the world. It's still 0, 0, 0. I'm going to assume, because I copy pasted the code, this is all we should be able to do. Honestly, can we just see? Yeah, he like jumps around and moves. Eventually this will be our goal. Jumping and squashing monsters. Yep, great. Jump, jump. The content for this page was not updated for Godot 4.2 and may be outdated. Am I missing something for Godot 4.2 to actually get it moving? Yeah, they have the C# version too. I believe so. Nobody has corrected me yet. I used to call it Godot. Godot. Yeah, Godot. Godot. Godot? Or no, Godot. Godot. I really hope it's not anything to do with being 4.2. We're gonna keep moving. Let's create the monsters. All right. New scene. It's gonna be our monster scene. The root node is a character body 3D. We're gonna name this Glob. Not Glob, Mob. This gets a node 3D. We rename that to Pivot. drag and drop the file mob onto the pivot. So let's find the asset, put it here. Let me call this character. Dope. Yeah. Character. We need a collision shape. That's a monster. Look at him. So, if I remember right, that goes here. Collision shape 3D. And then we set the shape. We're going to do a sphere. And then we're going to have to update the... Oh, maybe I lost something. So create the collision shape, set it to... Oh, no, it wants a box shape 3D. Change the box to fit the thing better. Got that. We're going all the way to there? No, it just wants it to be on the main body. Right there. And there. Notice the box is taller than the monster. Okay, like that. Yeah, this is going to come down to the game mechanics. Like, how easy do we want it to be to smash a monster? Because if we make our collision box there, we have to jump higher. But if we set it to, like, right there-ish, you know? Okay. Let me save all of this. This is a mob. Great. And I want to show JD my script. The movement should be that first part of the tutorial. Yeah, I mean, we already set up our input map. Project settings. On the input map, we set all of the keys to fire off these actions. And then here we're checking them. Which part do you want to see? Also, JD, I mean, you can look at their docs. As I copy and pasted the code exactly from here. This section is the codes that we have. All right. I want to keep moving. Yeah. What, Limeoats? This is great, Nob. What if I told you we could talk about JavaScript frameworks instead? This is fine. I'm getting a little, I'm kind of exhausted. I've been standing for 2 hours and 47 minutes, but we're going to get through this. All right. Once a monster leaves the scene, we don't want or need it anymore. Target velocity is the issue. It needs to be tabbed. This one? This one. This one? This one. This is cool. All right, we're gonna keep moving. But we'll come back to the player movement because we won't be able to play the game if it doesn't work. 28 and 29. Yeah, these should be at the same level as this. So we do our calculation, and then based on the direction we just calculated, we set it here within that method. That's my understanding anyways. Maybe this will help. So it's been merged, but maybe it hasn't been deployed. 100 files changed. Okay, we specifically want the section on moving the player with code. This has already been merged. Yeah, because they renamed it from velocity to target velocity, and our code is that. Let's just go to the section where they have all the codes. Here is our complete code for reference. Target velocity. Checking direction. So in the old version, they are reassigning velocity to be the result of move and slide. But in the new version, they don't reassign velocity, they just call move and slide. Is that inaccurate? And for move and slide has no arguments. Okay. All right. Can we see what move and slide does? It's just a built-in method. So you would right click, look up symbol, and then this tells you in the documentation what it does. But depending on how all this works, we may not be able to see the source code for it. It's just a built-in method that we can call. So it moves the body based on velocity. If the body collides with another, it will slide along the other body rather than stop immediately. Modifies velocity if a slide collision occurred. So it will update the velocity. Okay. Can I print velocity after it's set? Yeah. Is it something wrong with my camera? Raise the... Oh, am I am I colliding with the floor right now? Is that the main issue? That's actually really funny if that's the case. Am I... Yeah, am I inside the floor? Okay, so we go player. That's why I was colliding with I'm inside the floor. I bet it told me to do this at some point. Yeah, so actually the real thing to do is if I put it like this, because our code says it should fall back down, now when we start the game, yeah, now it falls. There we go. Yeah, I was colliding with the floor. Wow, good call, JD. Thank you for that. Though I am not dropping back down. I could go. Let's go like way above. Yeah, so that way I drop into the game. That's a cool little like animation too. What's up, Alka? Honestly, we could stop here. This is a great game. Look at this. I can move around. Look at me. Someone else mentioned clipping? Well, I don't know what the term clipping means, so that's on you for using words I don't know. Shadow doesn't make sense. I think you're still not on the floor. Maybe it has to do with our script. If in the air, fall towards the floor. Literally gravity. Well, so the other thing is it probably has to do with our collision box as well. So on our player, our collision shape how do I? Yeah, our collision shape is too far down. I didn't see that. That's why. That's why there's a shadow. I need to get that, like... Yeah, thank you, JD. No, I really appreciate it. Now, here is our collision. So now it'll have less of a shadow. Because the collision is less. I mean, we can even do this, and then we... Yeah, then we phase through the floor. The thing is, I can still move around because technically my collision is there. Yeah. There we go. It's good enough. He's got a round belly. That's why there's a little bit of a shadow, because his belly is round. It is perfect. All right, now on to the monsters. Yeah, thanks, JD. Actually, I mean, have we... I don't think we've even shouted you out. You do stream, though, don't you? Yeah, I'm following. I'm following. Nice. Yeah, good job finding the bug. I mean, it's definitely a beginner mistake, right? Because I'm learning a bunch of stuff right now, and I would have never had thought that collision was the culprit here. But I guess what we did learn though is now that we have it working, honestly, that might be it might be worth adding to the tutorial. I don't know, because telling me to make sure the player is like above the game would fix that, because now when I start the game, it falls in because it was above. But before, if it starts inside the floor, there's no moving and there's no fixing it. All right, let's work on our bad guys. Okay, so same thing here. I need to make sure that the collision shape... Yeah, I see. I wasn't looking at it from this angle. Now the collision shape is like probably too far on the ground. And then I can probably also not make it as high, so the game's a little bit easier, like right there. Yeah. Cool. So we did all this. We add the collision shape. We set the collision box. Now we're on to removing monsters that are not on the scene. Though we haven't really even added monsters to the scene yet, but I'm guessing these monsters are going to be randomly moving, and if they go off the screen, then we need to remove them from the game world. Godot has a node that detects when objects leave the screen. Visible on-screen notifier 3D. Okay. Select the mob node and add a child called visibility notifier. Resize it using the orange dots until it covers the entire 3D model. All right, ad break soon. We will get this. Oop, oop, oop. Oh, we want it to be the full thing, because otherwise it would leave the scene the moment like half of it was missing. Finish the game for the ad break. I don't think I will. Oh, this needs to come down a little bit then. Its back is sticking out. Okay. And then a little bit more. Is there no bounding box for each such cases? That would be nice, wouldn't it? Just be like a line with bounding box of our little character guy. This should be fine. This is fine. All right, now we code the movement. We're going to attach a script to the mod. I think we choose... It doesn't tell me, but last time we chose... Yeah, last time we chose object empty. Okay. "30 seconds till ad." Let's we'll speed run the thing. I guess the speed run here is to just copy paste the code. This is the speed run. All right. We now should have a thing, and now we want to spawn the monsters in 20 seconds. Project settings, display, window, width, create the spawn path. I'm not gonna be able to do it. I'll take a step back. We're gonna try to understand this code before we dive in. All right, I'm gonna take a. I gotta sit down. I wanna finish the 3D game walkthrough, but it looks like this is probably all we're gonna have time for today. But I do after we get this working, I at least want to start from scratch, create my own basic scene, and then try adding like a 3D model that I find online and get it moving around. Like maybe I find a car, and then I can like get it to move around on the screen or something like that. But that's the plan. It's probably going to take me another hour and a half to get all of that done. Finish this game, and then try making our own little tiny game. That's what we'll do. But I am going to take a 5-minute break, so I'll see you all soon. I'll leave you with some... Actually, I can leave with a YouTube video. Let me do that. Yeah, it will be fun. Like, once we get the basics down, it will be fun in the future if we specifically set out to build a game with Godot. That would be great. All right, do I have a 5-minute video I can show? Yeah, I'll show you this. Now, we're gonna do all of that today. If it takes me 3 hours... We're here till we're done. We're here until I have a little car moving around on the screen. That's how long we'll be here. But yeah, let me leave you with this. And I'm gonna take a break while this video is playing. So this is Try-Day Friday from like 2 weeks ago, where we tried HTMX. It's like a 5-minute highlight of that. Oh, it's good to hear, Alka. Unreal Engine would be fun to try at some point too. Let's do it. We're gonna do HTMX. What are we gonna make in HTMX? We don't know yet. We're gonna make a game plan. Let's do it. We're gonna do HTMX. What are we gonna make in HTMX? We don't know yet. We're gonna make a game plan. Step 1, learn. We wanna know, what is HTMX? What is it used for? What can we build with it? How do we get started? Once we get here, we'll actually like write some code, but first we need to figure out what it is. Yeah, and that's the thing, is I've seen the Twitter memes about it. You know, I've read about it, but for now we're gonna properly sit down. So here's their website, htmx.org, high power tools for HTML. HTMX gives you access to Ajax, CSS transitions, WebSockets, and server sent events directly directly in HTML using attributes so you can build modern user interfaces with the simplicity and power of hypertext. And so this already was my basic understanding of what HTMX can do, where essentially the code can replace elements of the page based on the response of a server. So for example, we pull in the library. So this is the one thing I didn't realize, as it actually is just a client-side library. The backend that you create is literally just returning HTML. Whenever this button is clicked, it's going to make a post request to the backend at this route /clicked. And whatever the response is will be replaced right here on this button. That's it. I can build a node.js app that returns HTML from a post request to a URL. I can do that. That's easy. We know the entire framework now. Cool. Okay, so here is what I'm tempted to do. Based on their homepage, I just want to make this work without even reading the docs. Let's do that, because that will be fun, and we'll see if it really is as easy as they say. Here's what we're going to do. We're going to create an Express API. So my Create Express API creates a pure JSON API, but we'll need to augment it potentially with server-side rendering. Initially, we don't even need that. We could literally just send back HTML. Here we go. We have an Express app. It's serving up JSON data, but what we want to do is serve up an HTML file instead. I'm going to just use what I know along with what I just learned on the homepage to make it work. So we have a public directory. Inside of that, we have an index.html. We'll just create a basic HTML file, and then let's get this page served up. Right here, we need to add the static file handler, and then I specify the public folder, and then I'm going to get rid of my root handler because this root handler was serving back JSON, but now when a request comes in, it'll first look in the public folder to see if it can serve it up. Let's see if I did that right. I did that right. I at least know what I'm doing. That's a great idea, Oscar. We're going to add Pico. Think of it like Bootstrap, but we don't have to add classes on anything. Now, instantly, it looks nice. It has a better font and background and everything. Okay, we have a web page. Now we want to do a thing. What this example is telling us to do is to load HTMX from a CDN. And then now we're going to have a button that says click me. What should happen is it makes a post request to my backend. Now I click this, 404 not found. So I need a backend route /clicked that will return some HTML. I'm just going to do it in the root right here. When someone makes a request to /clicked, I am going to send some HTML. I'm just going to send back an H2 that says good job, and that should do it. So if I click this, it says good job. It's that easy. I mean, at this point, we know how to create backend routes. We could do whatever we want at this point, right? We could have put this route anywhere. We could have put it in like /API or whatever. And then as long as it's returning HTML, you're good to go. It's amazing. That was easy. That was HTMX. No, we need to figure out, we need to build something proper with it. So we'll go to their docs. We'll learn a little bit more. We'll see what else it's capable of and then figure out if we actually what else we want to build. What is HTMX? It's a front-end library. I literally never heard anyone mention that, and that fits better in my brain in terms of knowing what HTMX is. What is it used for? Making HTML pages interactive without extra JavaScript. Everything is done through HTML attributes. What can we build with it? Anything front-end? Must have a custom backend that responds with HTML. Why should we use it? We haven't gotten there yet. we haven't read about, well, what makes this better than anything else that we're doing? I would think anyone that isn't as comfortable with front-end JavaScript, right? So like, because your backend can literally be anything, devs that are already used to building backends with Rust or Go or whatever else might be interested in this because they don't have to learn a front-end framework. We literally only looked at the homepage. This is literally all we've done so far. We have a lot more to learn. How do we get started? Add HTMX to an HTML page. This is what was new to me. I didn't actually realize that it literally is just running on the web page. It has nothing to do with your backend. Basically, they have things that you can use, and as long as your backend responds in the right ways, we'll just work with HTMX. That's pretty cool. I feel like doing it all with vanilla JS and HTML and CSS is far more complicated to learn than just using a framework, no? I would say a lot of people that like HTMX, maybe they don't want to get involved with the complexities of like front-end frameworks and front-end development, and this makes it so that all the front-end code you write are just attributes, and all of the logic can stay on the back end like you're used to. It's amazing the effort we put into to not use JavaScript, yeah. Kind of like jQuery but for HTML. I think that's a good analogy, yeah. It basically adds all these new features to HTML. Yeah. Hello? I'm back. No, I'm back. I'm back. All right, let's. If you're just joining us, that was a video. I mean, you could probably tell by the edits and the choppiness, but this is now live. I'm here, probably with between 4 and 10 seconds of delay to you. Hello? We're going to keep learning about Godot. So far, we have this game where we can move around like this. But what we're going to be doing next is we're going to spawn these little monsters, and then we're going to have to jump and smash the monsters to get points. That is our game. We're following the Godot tutorial. We can't jump yet. No, we haven't added that. But right now, we're going to add the script for the mob. I'm going to start back at nothing, and we'll do it gradually. But we're adding the script for the monster to describe its movement. So there's a min speed and a max speed. And then move and slide. So this is what we did earlier in the player script to define what happens when we're pressing the arrow keys for it to move. So similar to the player, we move the mob every frame by calling move and slide. This time we don't update the velocity every frame. We want the monster to move at a constant speed and leave the screen, even if it were to hit an obstacle. Cool. So I'm guessing next we need to spawn it somewhere randomly, like with a random speed, something like that. We need to define another function to calculate the velocity. This function will turn the monsters towards the player and randomize both its angle of motion and its velocity. So the monsters are going to gravitate towards the player. Takes a start position and the player position. Yeah, so given where the mob is and where the player is, we want to direct the mob towards the player. And then we randomize the angle. Okay. So this is another method we're learning about. Scripts can have an initialize function, and this is going to get called from the main scene, apparently. Look at from position. So from the mob's start position, look at the player position. Look up. Is what that says. And Murdoch, thank you for the bits. Chat and drop game still on break. What do you mean? What do you mean? Oh, the tree is on break. Well, I turned it off because it kept getting in the way of the code. We'll leave it on until it gets in the way, but it's probably going to get in the way soon. All right, and then rotate Y. So rotate this mob randomly within the range of -45 to +45. So random F range is random float within range. So start here, end here. So this will be between -45 and +45 degrees. We'll get a random value, and we're going to rotate it in that direction. The Y we learned isn't that the up and down? I see. Okay, yeah. So look at the player and then randomly don't exactly go directly, because if we went directly towards the player, the game would be over like immediately, right? Like all the mobs would surround the player. So this like offsets it randomly. Okay. Everyone's only here for the drop game. Yeah. All right. We got a random position. We now need a random speed. So this is a random integer within a range. Will be useful as it gives random integer values, and we'll use min speed and max speed. So yeah, we declared these so we can use them to figure out what the speed should be based on our min and our max. So get a random speed value between min and max, which we defined up here. Change our velocity based on that random speed. and then move towards the Y position. Okay. All right, so earlier we added this visible on-screen notifier, so now these things are going to be randomly moving around, but when they go off the screen, we need to actually remove it from the game. Head back to the 3D viewport by clicking the 3D label at the top. Select the visible on-screen notifier 3D. On the right side, navigate the node and double-click the screen exited signal. What? Navigate to the node dock. Am I looking at the wrong thing? Oh, node. Node? No. Node? Node. Okay, this button. The node out here. Okay. And then it says double click on screen exited. All right. Yeah, and I saw somebody in the chat just ask about it. These are pinned tabs. So I have like my Streamlabs alerts, my Twitch ad dashboard, my stream events, Twitch chat, YouTube chat. They're just pinned. If you in Firefox, this also works in Chrome. If you right click and pin it, it makes it a little tab right there. So that way you can't close them and it just makes them tiny. But yeah, those are pinned tabs. All right, we double clicked it. Now connect the signal to the mob. Connect. Okay, that adds us a little function right here. On visible on-screen notifier 3D screen exited. this is an enterprise Godot right here. Cool. Call the queue-free method. Our monster is ready to enter the game. In the next part, you will spawn monsters in the game level. Here's the complete mob.gd for reference. Fairly simple. So on every tick, we're moving, but when we get initialized, we have an initial random velocity and initial random y direction. So this gets set once, and then because of that velocity, we then start to move as the game starts. And then if we're moving and we ever exit the screen, we call queue-free, which is a built-in method, which I'm guessing the main scene knows about that, and we'll remove the object from the game. All right, next up. Yeah, everyone's trying to burn the tree down. You guys need to stop it. Please make your function name more declarative. Exactly. Okay. Spawning monsters. In this part, we're going to spawn monsters along a path randomly. By the end, you have monsters roaming the game board. Double-click on the main, and then we'll change our game resolution. All right. Back to the main scene. It's a little bit, everyone's being a little bit negative, right? But they're trying to burn the tree down. We could have a game mechanic for this, where if there's a certain number of flames, the whole tree disintegrates, all the drops fall off, and then it starts new. Maybe. Okay. Before drawing the path, we're going to change the game resolution. Now everyone's just dropping flames to spite me. That's okay. We're going to set the window size to 720 by 540. So we go to project settings. General. Window. 720, 540. There's a 90-second timeout on drop. All right, now we create a spawn path. We didn't do the 2D game, so I don't know what they're talking about, but we want a random path around the game where we're going to spawn monsters. To find the view's limits, we can use some placeholder meshes. Your viewport should still be split into 2 parts. Oh, people are trying to put the fire out. Nice. Select camera 3D node and click the preview on the bottom one. Two viewports? Okay. And then this is the perspective view, which is still a little off. Where's our player? Oh, I see. We put our player way above, which is why we couldn't see it. Okay. Now we're closer to what they're saying. Let's add the placeholder meshes. Add a new node 3D as a child of main and name it cylinders. Main. 3D? Node? What does it want? Node 3D. Cylinders. We'll use it to group the cylinders. Select cylinders and add a child node mesh instance 3D. Okay. Make a cylinder mesh. Go back to inspector. Cylinder mesh. Select the top viewport. Set the top viewport to the top orthogonal view using the menu in the viewport's top left corner. Okay. The grid may be it's not distracting. I'm going to keep the grid on. Yeah, you have to wait 90 seconds between drops. Oh. I mean, okay, so shout out to Doc, who we haven't seen in years, but they're the ones that wrote the collision detection. It literally detected the collision at like the top of the flame. That was great. Yeah, fantastic. It's beautiful. Okay. You want to move the cylinder along the ground plane. Looking at the camera preview in the bottom viewport, I recommend using grid snap to do so. Grid snap? Grid snap. Move the cylinder Oh, there it is. Okay, we're moving this cylinder now. Probably Hugo. I get yeah. Not quite though. I updated the drop game today to use an image proxy, so the proxy would probably fail before the image download completed or something like that. I hear you, Matt. People are having fun. It's cool. Okay. Move the cylinder so it's right outside the camera view in the top left corner. Right there. We're going to create copies of the mesh and place them around the game area. Oh, are these going to be spawn points? Press Control D to duplicate the node. Command D for me. You can also right-click the node and duplicate. Yeah. I don't think I broke your Stony, unless that's the main thing I was worried about, honestly, because before the images were downloaded from my IP address. So I didn't want that anymore. So now they're loaded via the DuckDuckGo image proxy. No, I think we might keep the tree. So okay, I'm getting off topic, but we should think about what should we replace the tree with. I want to keep the collision detection mechanics. Yeah, let's see if that works. Stony. But what will the drops land on? I like the idea of like kicking the other ones off. Do you have like an IP whitelist on that CDN? Yeah, let's think about it. But I think I have to manually move these things now. So now cylinder 2, I'm going to move down to here. And then cylinder 3, I'm going to move over here. And then I'll duplicate that one and move it over here. So now we have 4 cylinders. I see. Oh, it could be the image proxy doesn't support SVG, something like that. Yeah, I think that's the issue. They're a bit hard to see in white, aren't they? Yes, that's what I'm saying. I can't see these cylinders. Select all 4. Oh, I'm only supposed to be duplicating the mesh instance, not the entire cylinder. Cool. What's up, Giorgio? Welcome in. All right. Select all of these. Now in the inspector, we can click this. In the inspector, expand the material section. Okay, this is the material section right here. We want a new standard material 3D. Thanks, Drills. And hello, Drills. I don't know if I've seen you in the chat today. Click the sphere icon to open the material resource. Expand the albedo section. Set the color. Let's make it orange. Cool. Though these two look rotated. What's up, Jules? Yeah, my mindset is great. It's doing just fine. Any max size restrictions? I would say look into the if you go on DuckDuckGo, search for an image and then right click the image location, you'll see the what the proxy is. It just is like it's a DuckDuck URL and then URL. You could test it with that to see if your images load. All right. They have color now. We can now use the cylinders as guides. Fold them in the scene dock by clicking the gray arrow next to them. Cool. Okay, here's the thing. Like this one, I want to get it better lined up. Like here. And this one too. Okay. Add a child node path 3D to the main node. Main node. Path 3D. Click the add point tool. Add a point. Click the center of each cylinder to create a point. It's not a full square. The drop game is called Christmas Drop on GitHub. Oh, I have to click close curve in the toolbar. Close curve? There we go. Our path should look like this. It's close. Yeah, it's good. These two cylinders are like slightly rotated, but I don't think that's going to matter. Maybe it won't matter. To sample random positions on it, we need a path follow 3D node. Add a path follow 3D node as the child of the path 3D. Spawn path and spawn location. So this is spawn path. It's a spawn location. Now we need to code up the spawning mechanism. Okay. Now we add a script to main. Node default or object empty? Yeah, eventually all that's going to be in the mono repo and all the overlay games and everything too. It didn't tell me which one. I'm just going to go with the default. Yeah, extends node. We want to create a mob scene. Spawn mobs at regular intervals. Go back to the scene and add a timer. And we need to assign the mob scene to the pack scene. Okay. Head back to the 3D screen, select the main node, and drag mob from the file system dock to the mob scene slot in the inspector. All right, head back to 3D. Oh, here it is. So it creates this little thing over here. And we want to pull the mob scene, this one, to connect it here. So look at that. So now this is linked up to the actual scene. Now on main, we want a timer. I'm going to call it mob timer. In the inspector, set the wait time to 0.5. Auto start on. Timers emit a timeout signal every time they reach the end of their wait time. By default, they restart automatically, emitting the signal. So yeah, this is going to fire off every half a second and we'll spawn a new monster. With the mob timer selected, head to the node dock on the right and double-click the timeout signal. Okay. Connect it to the main node. So now, inside the script for main, we know when the timer times out, and this is where we will spawn a new mob. So, create a mob, spawn it at a random location. So mob scene, which we connected up, we can instantiate. That's now going to create a monster. We're then getting a random location on the spawn path. So we with this spawn path, we set up a square. It's going to give us a random location within that. Or actually, no, a random location along that blue line. That's our path. So we pick a random location along that. That's where we will spawn a mob. Give it a random offset. So we grab where the player currently is and then initialize the mob. Because if you remember, our mob, when we instantiate it, points in the direction of the player and then offsets randomly. So it needs to know about the player. Great. And then we add it to the scene. So add child, I guess, is built into node to allow us to add that new node to the scene. Yeah, this should work. So now if we start the game, we should just every half a second we get a new we get a new monster. That's great. But we're gonna have to code up what happens when two mobs collide with each other. If a mob collides with us, I think that's game over. They're just piling up. But that's cool. Jumping and squashing monsters. Let's give our physics layers a name. I skipped a bunch, but I'm just trying to move along here. Okay, project settings. On the left, we have 3D physics. We do. No, layer names. 3D physics. Oh, wow. Okay. So each of these different types of things are going to have their own layer of physics. So we can make it, this is my guess, I'm guessing based on what I'm seeing here. We can make it so that the enemy's physics layer, they do not collide with each other. I think that's what's going to happen here. So we have 3 layers, the player, the enemies, and the world. Okay. Now, we go to the ground. In the inspector, we set up collision. And that has, I'm hiding it, but that has collision. We can choose the specific layer that we just named. Ground is part of the world, so we set the layer to be 3. The mask property allows a node to listen to interaction with other physics objects. But we don't need it to have collisions. Ground does not need to listen to anything. It's just there to prevent creatures from falling. So no mask? No mask. So here we just say this is world. Yeah, so this says toggle off the mask. Great. You're right. I'm not taking notes. I'm just gonna remember everything. it's gonna be fine. I'm almost 4 hours in. I don't really have the energy at this point. I just kind of want to get it done. All right. Good. Next up on the player, we're gonna do the same thing. So for a player, we will set its collision to be player and world, I'm guessing. Select the player node and set its collision mask to both enemies and world. So here we are masking for enemies and world. And we leave it with just player for the collision layer. Great. Now, for the mob, mob. For a mob, we have collision. We set it to enemies and remove player. And then what is the mask going to be? Collision layer enemies, and then mask is empty. Okay. These settings mean the monsters will move through one another. If you want the monsters to collide with and slide against each other, turn on the enemy's mask. Okay, so because we don't have the mask on there, now those monsters are just gonna phase through each other. Yeah, they don't care. They don't care about each other. But they do technically collide with us. Yeah, so they do move us. And right now you can see that like some of them are gliding past it, and that's, whoa! He took us off the screen. That's awesome. We could change our collision box on our player to be bigger, so that way, but I think the smaller it is, the easier the game will be. All right, now we need to set up jumping. The jumping mechanic only requires 2 lines of code. In the player script, we have our jump impulse. And then we detect jumping. Where? Add the following code before the move and slide code block. Here? No, this would need to be before this. If not on floor, if is on floor. Can't we just do like an if else? I bet I could do an if else. How does an else statement work? Oh no, but this is including a check for input, so we're not going to combine them. We could though. We could say if we're on floor, and then inside of that have an if and an else on the top one. It doesn't matter. That should be it. Now we can jump. Look at us. Yeah, now I can at least get out of the way. Yeah, and so now if a monster is pushing me, I can jump and then I stop being pushed. What's fun though is if I jump, I'm in the air and I can still technically like set my direction when I land. Cool. No. Okay. Now we need to set up squashing of monsters. Okay. In the mob scene, we basically are going to do collision detection, but collision detection to determine if it's coming from the top. So if it collides on top, then that means we squashed it. Yeah, and Coder Girl says, this is fantastic to watch the evolution of the game. Yeah, it's, step by step. I have the chat on another screen, yeah. Except I don't have YouTube chat. Oh no, Jules, I'm gonna take it slow because it's not just about consolidating, it's also about refactoring. So it's not just copy and paste the code into a new project. Every project is going to be built from the ground up to make sure that it has good types and that they're sharing the right code and everything. Yeah. That's my plan anyways. I think once I get a good base, then I'll accept contributions, but yeah. Yeah. I'll let you know when it's like completely open to contributions. For now, I'm going to mostly do it on stream. All right. Back on the mob scene. Open the mob scene. We have that. Go to the node doc. This thing. And then groups. Signals, which we used, in groups. Click on it. Add it. Okay. An icon appears in the scene doc to indicate that the node is part of at least one group. There we go. That little icon says we're in a group. We can now use the group from the code to distinguish collisions with monsters from collisions with the floor. Okay. Now, in the player script, we're going to code squash and bounce. So a player gets a bounce impulse. This is a lot, but this says after the jumping code block, with move and slide, Godot makes the body move sometimes multiple times in a row to smooth out the character's motion. So we have to loop over all collisions that may have happened. In every iteration of the loop, we check if we landed on a mob. If so, we kill it and bounce. With this code, if no collisions occurred in a given frame, the loop won't run. So I'm thinking we do this after move and slide. Gotta get my white space right. Okay. So after we moved and slide, we figure out how many things are we colliding with, and then for every collision, We check to see. So if the collider is null, then that means we collided with the ground. We don't want to do anything else. So continue means don't do the rest. But if it wasn't the ground, that means we collided with the mob. So if we just collided with the mob, we need to check to see if we collided from the top down. So get the collision. And if the up vector is greater than 0.1, that means we have landed on top of a mob and we squash it. Did we implement the squash method on a mob? No, we're going to have to implement that. So we're calling squash on the mob, which will like remove it from the scene. And then by setting the Y velocity, we now bounce off of the mob using this bounce impulse of 16. So if we land on it, we then bounce off. And then here we break out. So basically the first mob we collide with, we kill that mob and then we bust out of this with a break statement. Okay, my guess now is if squash is squash a built-in function? It's not. We're now going to need to implement squash. So on the mob, we implement squash. It can't find this, which I'm guessing is we need to create another signal that's going to be emitted by the mob, which is the squash signal. So yeah, we need to define a new signal named squashed. So signals. Oh, I'm missing. It's here. It's here. I just need to put it at the top of the file. So yeah, we have a squashed signal now. Great. We'll use this signal to add points. So yeah, whenever a mob is squashed, increase the player score. With that, you should be able to kill the monsters by jumping on them. All right, here we go. Come on. Come on. It's so hard. Come on. I can't. Got him. Here's the thing. Whoa. That's so funny. I think because of my, I think I can't die. I think because of my collision box, technically I'm always on top of them. Let's fix that. Let's fix that. So if we go back to main, perspective? No. Orthogonal? How do we get rid of this? It told me to open this view, and I don't know how to get rid of it anymore. The view menu? Is there a view menu? View. I just looked at it. I want the 3D view so I can control the location. Actually, no, never mind. I shouldn't be doing this. I should be doing it on the player. This is what I need to control. And the collision shape. Like that, maybe? Like a little further up? I'm just curious why it's detecting as a top collision. Maybe we have to code that in? Yeah, it's detecting everything as a top collision, it feels like. Maybe we're gonna fix that? Is it the monster collision? The thing is, in our collision code, this is supposed to check that we're hitting it from above. Put the collision on the player lower. So the opposite of what I was doing? Like that. No, it still seems to jump. Let's get our mob. And then its collision shape. I see. So like I think we want to raise up this box a little bit. Yeah, we want to do like this. I think that was it, right? Because now, yeah, that's what I want to see. So now because the collision box is higher, it's not on top. Okay. And we can make it even harder. Like do like that. Yeah. Cool. Next up, kill the player. Go back to the player. Add a new child node called Area 3D. So player. Area 3D. Mob detector. This gets a collision shape 3D as a child. All right. Assign a cylinder shape to it. So over here on the inspector, we give it a cylinder shape. Here's a trick you can use to make the collisions only happen when the player is on the ground or close to it. You can reduce the cylinder's height and move it up to the top of the character. This way, when the player jumps, the shape will be too high for the enemies to collide with it. Okay. How do I... Oh, it's this. Okay. Or is it? Make it this. And then... this. And then, okay, we'll get there. Honestly, one of the biggest learnings here is getting used to the 3D editor. So this is saying put the cylinder thing on top of the player. I'll make it a little bit wider. Yeah, it's like, I guess I don't, do I want it? I want it like there. Like that. Great. The wider the cylinder, the more easily the player will get killed. So yeah, now anything that would come in, any mob that comes into contact would kill it. But here we're just going to make it like that. Okay. Select the mob detector node again. Turn off the monitorable property. I see. So other physics nodes won't collide with that, but we can use that. And then monitoring allows us to still get collision detection information. Remove the collision layer and set the mask to the enemy's layer. When areas detect a collision, they emit signals. We're going to connect one to the player node. Select the mob detector, go to the inspector tab, click the body entered signal, and connect it to the player. Body entered. Connect to the player. On mob detector, body entered. Great. This will emit it when a character body 3D or rigid body 3D enters it. As it only masks the enemy's physics layers, it will only detect the mob nodes. Okay, so this is basically how we're going to be alerted that we have been hit and we end the game. Yeah, so if we are hit, we then die. So we're going to have a hit signal that we can fire off. I guess we fire off the hit signal so that the game can show like the game over screen. So when we die, let the world know that we have been hit. Q free? I guess I still don't know what Q free does. Q is a node for deletion at the end of the current frame. So yeah, that would remove the player. And then when we get hit, we die. Cool. So this, now if they collide, player disappears. And then the code errors out, which is what they're telling us about. All right, we're on an ad break though. So I'm going to take another quick 3-minute break. And when we come back, we're almost done. We're almost done with the game. We end the game. We'll probably have a variable where we keep track of score, like how many mobs we have squashed. And then we'll have to create a UI for like restarting the game. We're almost there. We're almost there, everybody. All right, back in 2 minutes. We're back to finish the game. We're close. This is a long one. Wait, who did that? Elka. All right, I gotta call it off, Elka. It's gonna take up a lot of the screen. Now everyone's gonna do it. I was eating a what do you call it? A kind bar. It's just a little granola bar. You photoshopped it yourself. It was cool. It was cool. I remember when when we first had the drop game a while back, people were doing that with like their own custom images. Yeah. All right. All right. All right. Oh, look at that. It's a little. It's the player. Now we end the game. So we already made it so that if we collide with a mob, we end the game. This was letting us know though that there is no more player. Yeah, so like this code doesn't make sense anymore because when we collided, the player doesn't exist anymore. So we probably have to do something like if player is a thing. Or something. I don't know. Okay. Am I able to scroll the whole image in my chat? Yeah. Check it out. Why is there an icon for my mouth? Oh, this is the tooltip we created. But it doesn't know what to say because you don't have a name on it. But yeah, look at that. Very good. That's a good Photoshop, Elka. Like the texture. All right. Now I got to end the game. We can use the player's hit signal to end the game. All we need to do is connect the main node and stop the mob timer in reaction. Actually, I guess that's the other thing is we won't do this because when the game ends, we're going to stop spawning things. Right? This is the mob timer, so when the game ends, end it. Open main. Select the player. Connect its hit signal to main. Now, when the player is hit, we stop the timer. How do we do that? Mob timer. Stop. Great. So now, when we get hit, game is over. The mobs stop spawning because we stopped the mob spawning timer. Great. Here are the complete scripts. I think we're good. Let's calculate the score. So on the main scene, we need a control. Main add. Control. We're going to call this user interface. And then what do we do with it? Then we add a label. And this is going to be the score. The score label. Okay. I see you later, Coder Girl. I appreciate you. Thanks for hanging out. Yeah, welcome back, The Real Droid. Yeah, that's how the tooltips work. Yeah, I guess you missed, I don't know how long you've been gone, but we can now jump, we can move around, if we collide with a mob, the game is over. So now we're handling in-game state and also showing a score. So we need to be able to, yeah. So there we go. If we land on top of a mob, we kill it, and that should increase our score, like that. But if we don't, then we collide and we die. Okay. In the inspector, set the label's text to a placeholder like score 0. Inspector, text, score 0. Oh. Does that just automatically show up? Oh yeah, it's in the top left. Look at that. We'll change the color. We want the control. And then on the control, we go to theme overrides. There are no theme overrides. Am I missing something? Is it on this? Oh, it's on the label itself. Theme overrides, colors, font color. We'll make it black. Let's see. Okay. Great. Now we can see the score. Now, I am gonna jump ahead because I think anytime we collide, or anytime we squash, we're gonna emit an event. Actually, no. We would actually. I guess would we handle this in main? Is there something in main where we know about when a squash happens? I guess not. If we look at the player node, there's a signal. There's a signal that happens when we collide, right? So if we look at the player script, oh no, squash. So when squash happens, we need to connect that up to main, because when squash happens, we increase the score. So if you look at the mob, when it's squashed, it emits that it's squashed. So over in main, we want to know when it's squashed. I forget how to connect it up, though. I think they're going to tell us how to connect it up, because right now the mobs are created programmatically. We don't have them over here, so it's like not showing up in signals. But we'll get there. All right. Drag the text away from top left corner. Great. Create a UI theme. I don't want to do that. Okay, so attach a script to the score label and define the score variable. So score label, we get a script. Score starts off as 0. Increase by 1 when we squash the monster. Yeah, this is what I was saying. We need to use that squash signal. And this is exactly what I was saying too. Because we instantiate the monsters from code, we cannot connect the mob signal to the score label via the editor. Instead, we have to make the connection from the code every time we spawn a monster. Open up the main script. This one. At the bottom, add the following line. We create a mob, and now we need to connect it. So when the mob is squashed, connect it to the user interface score label on mod squash.bind. So we'll do this down here. So yeah, this is programmatically hooking up that signal. So now the score label can be alerted when a mob is squashed. And then we have to manually define on mob squashed inside of here. We increment the score, we update the label. Done. That's all we need. Watch us. Boom! Score 2. Score 3. Score 4. Oh, oh, oh. Score 5. Great. We need some, like, now we need an in-game scene, and then we'll be done. Okay. We'll now add the ability to play again after dying. When the player dies, we'll display a message and wait for input. Head back to main, select unit interface, and add a rectangle. So on main, we want a child node rectangle. Color rect. So when the game ends, we're going to just draw a rectangle over the whole game. This is going to be our retry rectangle. To make it span over the whole viewport, you can use the anchor preset menu in the toolbar. Okay, so if we go back to 2D, we click our retry, fill the whole thing. Yeah, nothing happens. Only the 4 green pins move to the corners of the select section box. This is because UI nodes work with anchors and margins relative to their parent's binding. Select the user interface, anchor preset full rect. There we go. We'll change the color. So on the retry, we can set it to be black, but then we can also set the alpha so that the stuff underneath it is still visible. Okay. Now we add a label to this thing. Press enter. Hey guys, I'm trying to get this done and you're dropping giant kitties. Press enter to retry. Cool. Move it to the center. I can do that. Boom. Nice. Coding the retry option. In the main script, we will hide it. Okay, so in main, when the game starts, so ready, we're going to replace this. When the game starts, hide retry. So now, like without this, if we started the game, we have what? Unexpected indentation in... Oh. I can't just comment that out. Oh. Wait, what? I have to say pass here to get this to compile. Yeah, and so by default, the rectangle is there, but we hide it when the game starts. Cool. When the player gets hit, we show the overlay. That makes sense. So stop generating new bad guys, show the overlay, and then we will handle input. So yeah, this is interesting because now we're listening for input in the main script here in the main game. So if the retry thingy is visible, reload the scene if they press the UI accept action. And I'm guessing UI accept defaults to enter, or am I going to have to add that in my input map? But yeah, this says get the tree and then reload the current scene. All right, I'm not going to add music. Let's just see if this works. I'm guessing UI accept is default. Let's see. Press enter to retry. Yeah, UI accept is built in. Nice, okay. Great, we have a game. Oh, barely. Now it's more complicated. We want a character animation. There's an animation editor. All right, I need to make my own game now. Here's what I want to do. I'm going to find some 3D asset on itch.io. So itch.io has lots of game assets for sale, but they also have free assets. And I want to find something interesting, and then I'm going to create my own game that has some 3D model on it that can move around in it. That's what I want to do. That's my goal. Free? 3D? Cool. But 3D cat, moldy bread. Actually, we could. I mean, we could. Okay, let's see. Is there any? Is there a bread model? Moldy bread. Guess that wouldn't be a tag. Can I search within assets? This is the asset that I saw earlier today. Like this, they have actually created, yeah, this GitHub repo of a bunch of like retro assets that are all Creative Commons. And it has all of these cars on it. Kinney assets? Have not heard of it. Oh, they're like this company here. I see. Wow. All right. What if we just have like a spaceship and we can just fly the spaceship around? What if we do that? Because that's basically a game, right? How do I specifically search assets? Space. Voxel ships? Oh. Those are cool. These are also cool. Are they CC0? What's the license? You can use it for any kind of project that you have, commercial or not. My name and your credits would be appreciated. Yeah, I'm already filtering by 3D. Okay. This is it. Here's what I'm going to do. I'm going to modify my existing example. I'm going to get rid of all the mobs, and I just want to replace my player character with a spaceship. And then I'll probably change the ground to just be the color black so it'll look like space. That's what we're going to do. Here we go. Let me download this. Oh, which one do I want? The Dual Striker is cool. The Galactic Racer is cool. I'm going to do the Interstellar Runner. Okay, now we need to, I guess we're going to see, does Godot support these types? MTL, OBJ, or Vox? I'm guessing it probably supports OBJ. That's like one of the most common ones. So let me drop that in here. In art. Could not open MTL file. It may not exist or is not readable. I probably have to actually put it in the folder. Oh, it needs the MTL and the OBJ. I see. Okay, so let's actually just copy these into here. Now we have those two. Oh, and then it wants the PNG too. It wants all the things. It wants all the things because the PNG, I'm guessing, is like the texture. Okay. It wants all the things. Yeah, I'm just going to copy everything into that art folder. And then let me like save the project and then reopen it. Blend file import is enabled in the project settings, but no Blender path is configured in the editor settings. Blend files will not be imported. Okay. But if we go to the player scene, the character is that GLB file. I'm trying to remember if we had to do anything special with it. What happens if I delete it? Okay, character is gone. Can I replace it? No, I need a G. I guess maybe I need a GLB. Godot model supported formats. GLTF? Convert OBJ to GLB? Is this what I want? Are there any Godot people in the chat? Drops are getting out of control. All right, I used a free online GLB converter. What's the worst that could happen? Right? But now I do have this GLB file. So I uploaded the MTL, the PNG, and the OBJ. Let's see. Whoa! Nice, 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 nice. We got it. Look at us. Awesome. Now we have to change our collision shape. I guess we don't even need a collision shape. No, this is fine. Here we go. Now it's the same game, but instead we're a space fighter. Look at us. That's awesome. I could make it so I guess we could add to this where like I can also shoot at the the things. Change the gravity. I guess I could just like keep floating up. All right, I realize I didn't do that much extra custom stuff, but I think I have to go. I've already been live for 4.5 hours. Is there anything other? I think the other thing we might do is we could change the ground color. Let's do that so it feels like space. We're gonna change the ground color to be black. I guess we never did that, but I mean, I guess we didn't. We have a mesh, but we never actually set the color of the ground, did we? Ground is a static body 3D. Did I just get rid of the physics material? I think so. Now that we've at least learned the basics, yeah, it would be great to revisit this and try to build my own game without following a tutorial. Is it the mesh instance? Material. Standard material? Here we go. Oh, we did this earlier. Yeah, we did this earlier with the cylinders. Yeah, thank you, Redoxide. Yeah, so we set material, and then once we have the material, we can set the color? Shading. No. Oh no, it's this albedo. Yeah, it's that. I guess you can't see what I'm clicking on, but yeah, we did this earlier for the cylinders. So yeah, if we make it black, now we're in space. Here we go. Wow, it feels just like space. All these space aliens coming after us. True, we should update the label too. That's all I'm gonna do though. I'm gonna end it here because I mean, man, this was a lot. I think um, if I were going through the tutorial and not reading everything out loud, and also like relaying everything to everyone as I'm going, I could probably get through a lot more. But having to do all of this live and explain my thought process and everything else takes a lot. Takes a lot. All right. We built a tiny little game. We learned about Godot. I also think I have a good enough grasp of the whole 3D. Did you fix it, Stony? Of the whole way that 3D works within Godot. So like I do have confidence that I could try to build something of my own with this. Cool. All right. I am gonna get out of here. I'm exhausted. It was a long one, Ronald or Ronald, Ronald. But I'm gonna get out of here. Let me tell you about all my stuff. If you check out the schedule, I'll update it this weekend of when I'm going live next week. I'm probably not gonna go live on Monday, but we likely will have a Wednesday and Friday stream next week. Based on the voting that happened today, I should just call it. We're gonna do Java Spring Boot for next Try-Day Friday. That is what we will do. And Wednesday will be like a Web Security Wednesday again. But I'll update the calendar. If you look at the calendar, whatever the times were this week for Wednesday and Friday, that's going to be the same time next week. It's not updated yet, but it will be the same time. As long as nothing changes in my personal plans. All right. If you're not following me on YouTube, please do that. Also, follow me over on Twitter. And if you're watching on YouTube, definitely go check out my Twitch. We're about to go on a raid. So if you want to join us in the raid, head over to Twitch. Again, check the schedule over here. Join the Discord if you'd like to hang out with us or if you have questions or anything. And also, I have a mailing list. So if you want to get Go Live notifications in your email, you can join the mailing list. All right, let's go on a raid. If you are a sub, you can use this raid message. If you're not a sub, you can use this raid message. And I don't know who we're going to raid, but whoever we raid, show them lots of love. Drop a follow if you like what they're doing. Thanks again, everybody, for hanging out. Thanks for all the Godot people that were helping as I was going through the tutorial. That was much appreciated. And I'll see you all next week. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.